All right, time is 7 o'clock, so let us start on time. Thank you once again, everyone, for participating this 10 hours workshop on Advanced AI Certification Program. And today is the final day of our 10-hour session, jointly with IIIE and MTC Global. And on behalf of MTC Global family and IIIE family, we extend our heartfelt thanks to Dr. Jitesh Pradhan, who will be handling the session today as well, to complete the advanced certification program. And also, we extend our heartfelt thanks to all the participants for joining the session. Thank you so much, sir. And I hand over the session to you, sir. Thank you, sir.
Okay, thank you so much, sir. So, very good evening to all of you. So today we will start with the same point where we left yesterday. Okay, so little bit we will discuss about the transformer. Then we will be seeing a little bit about the industry 4.0 and AI and ethics and biases in AI. Then we will go for a live demonstration. Okay, we will have a hands-on session in which we will try to implement one problem, and we will try. I will provide some kind of a solution which will be a generalized one. Okay, literally by changing few lines of a code, you will be able to handle, I think, around 20 plus models. Okay, we will see that. Now, just a second, I am sharing my screen. Is my screen is visible to all of you? Is it visible?
Yes, sir. Yes.
Okay. Just a second. So, in last class, in yesterday class, we have left. Sorry. Okay, we have discussed this point now. Why transformer models are better than RNN. Okay. So now we have to move on forward. So we will start here. So now, okay. So as we know from the architecture of transformer itself that we'll be having two kinds of encoding. Okay. So it is two kind of encodings. So we will call this encoding as a input encoding, and it's called as a output encoding. Okay. Or we will call it a encoder encoding, or it's a decoder encoding. Okay. Now in encoder encoding, we have two things, embedding and position encoding. We will discuss in detail what is a position encoding. Right now you might be in confusion what position encoding is. So we will see with example how position encodings are generated. Okay. Embeddings, it is clear you can use any method. So we have already seen one hot encoding is there is a globe vector is there. So there are so many methods in which we can generate the embeddings of word. Okay. So once word embedding will be generated, based on their position encoding will be generated. Okay. How position encodings are calculated, we will see. Now, it is the encoder part. So basically it will be our input information. Okay. And it's a decoder part. It will be basically where we will try to feed our what we call it, our labeled information or our ground truth data. Okay. During the training phase. Okay. Now look at here. The word is "you are welcome." It's a pad written here. So basically it's a pad is nothing but it's a padding bit. Okay. So make the same length sequence. Here we are making 4 length word. So here it will be 4 length. It's a padding, okay, which represents the end of a string. So here we are writing "you are welcome," and it's a padding word. Okay. Now we have generated the word ID. It's basically what are the word ID? It will be the vocabulary where you are using. Let's suppose it's the English vocabulary. You are using some kind of encoding, globe vector, whatever you are using. There will be a word position and its ID will be there. So these are nothing but it's a word ID where 1 represents the padding bit. Okay. Welcome will be present at the 17th position. R will be present in the 62th position. U will be present in the 57th position in our vocabulary. Okay. Based on that, its embedding will be generated. So embedding means for this U word, which is present in the 17th, 57th position, there will be embedding now. Whatever embedding you are using, that embedding will be generated here. Okay. Now, the one thing you need to know is that word embedding and position encoding both should be of same length. It must be of same length. Now, let's suppose it can be generated. We can generate of a 4 length encode or embedding, 5 length embedding. It depends on you. Okay, whatever you are generating or whatever your method is generating. Now position encoding, we will calculate position using some sign cost method. We will see it later. Now what happens during the encoding process, or sorry, encoder process, this embedding, word embedding and this position encoding, both will be joined together. So how it will join? Basically the first position will be added with the first position, second position will be added with the second position, third position will be added with the third position. So it will be nothing but it's a basically addition operation between these. It's a kind of a element wise addition. Okay, first position will be added to the first position, last position will be added to the last position. So this is what it is, the input that we are giving to the encoder part. Okay, that decoder part where we have to, it's basically a translation na? From Hindi to Spanish we are sorry, English to Spanish we are translating. Okay, now during this decoding part, we have, again we will take two things. Okay, one, your welcome pad is embedded position encoding, it will be as an input. Okay, and during this output, how it is during the decoding portion, how it will generate it, the first position will be a start position where it matches now, because it is a u, based on u it will generate the d. Okay, here in decoding part also, we will, during the training process, we will feed this d nada, that is a word embedding, that is a word, its embedding will be generated, and at the same time its position encoding will be generated. Both will be fed to the decoding part also. Okay, now let's see how the position encodings are generated. Now look at here, just the position encodings are generated based using two functions. One is known as sine function, another is known as cos function. For a even position, we use sine function. For a cos position, for a odd position, we use cos function. Now, what is the formula? Is just it is PE means it's a position encoding. It is for a position. Okay, and it's a basically number of it. I is nothing but it's our index value in the dimension that we are using. Now let's say what is the dimension and what is the position. You can let's see what is the now look at here. It's a first word. Okay, in this case it is the first word now. So it, for a first word there will be this embedding size. Okay, so embedding size will be same for each word now. So for first word it will be embedding size. Now let's say we are using 3 word embedding here. For first word these 3 words are 3 embeddings are there. For second word these 3 embeddings are there. For third word these 3 embeddings are there, and for first word these 3 embeddings are there. Like it means for one word we are using a 3-dimensional embeddings. Okay, a 3-dimensional position encoding. Okay, so it denotes the position of a word position 1 2 3 4, whatever position it is. Okay, and now it is basically dimension. Okay, I represents the dimension. I value will be, if we are using 3-dimensional, the I value will be 0 1 2. Okay, now let's see, we have a position encoding. So for a position 1, let us assume we are talking about the first position. The I value can be, if we are using 3-dimensional in embeddings now, because our encoding is 3-dimensional, it means it is having 3 values. Okay, then this I value will be 0 1 2. Okay, 0 1 0 1 2, 3 values. Okay, then the formula will be sine divided by position. So position, let's suppose we are talking about the second position, so it will be 2 divided by 10,000, 2 power, if value is I's value is 0, so it will be generated like 0 into 2, it will be power 0, something power 0, it becomes 1. So it will be, if for 0 second position, it will become sine 2 only. Okay, and D model is what? It's your dimension. It's a basically dimension of your model. That means we can call it a dimension of your embedding. Okay, so P denotes the position here. Okay, and I denotes the it's basically index number in the vector, or we can call it an embedding. Okay, and this D model denotes the length of your embedding, or we can call it a dimension of your encoding. Okay, now based on this we generate a matrix. Now how matrix will be generated? Now let's suppose, because we can't input a single word now, we won't input a single word at a time, because transformer takes all the words or entire sentence at once now. So let's say we have a 4 words in this case. So look at here, we have a 4 words. Now let us assume that our 4 words are this: hello, my 5-word sequence. So for first word, this will be a 3-dimensional, or 3 element embeddings. Okay, for my it will be 3 elements embedding. For 5 it will be a 3 elements embedding. For word it will be a 3 elements in encoding. Okay, embedding. Or for a sequence it will be another 3 vector or 3 element based embeddings. Okay, so for our 5 words, it has created what? A matrix of size 3 cross 5, where 5 cross 3. 5 represents the sequence position. Okay, so for first, it will be the first position. Second, it will be the second position word. Third position word. Fourth position word. Fifth position word. And that cross 3 represents the dimension of your embedding. So basically, it's a nothing but it's a sequence length. In this case, its sequence length is 5, and it's a our that number of columns represents the encoding size. Okay, so based on that, it will create a matrix. So for this, what will be? Let us suppose if we are using a 3 word, okay, then it will create. We have a 4 words here, so it will create a matrix representation as a embedding here. The matrix representation will be of 4 cross 3. Okay, at same time, the position encoding will be having also same dimension. It will generate a position encoding for word 1, word 2, word 3, word 4. So it will be a 4 cross 3 position encoding. So basically, these 2 matrix will be generated. This is the matrix representation. Okay, now it will that what we are calculating, it's this position encoding in it is nothing but it's a sinusoidal waves. Okay, blue represents, look at here, 0, it is for even. Okay, 0 for this represent for even, this represents for odd. These are nothing but it's just a value generated from the sine and cos wave. Okay, now let's say how it works. So the formula is this position encoding. Formula is position 2i equals to sine position divided by 10,000 power 2i divided by d model. It's a formula. It's for a even position. It's for a odd position. Okay, just nothing but the sign has been changed to cos. Okay, now let's look at here. For first step, let us assume that we are talking about the second position. Now, second position means this position. It's a first position. It's a second position. Okay, so we have to generate the positional encoding for a position 2. And let us assume that dimension vector, okay, embedding dimension is 4. Now, in this case, dimension is 4. Sorry, it is 3. Let us assume that dimension is 4. There will be one more dimension here. Okay, embeddings has been generated with a 4-element vector. Okay, now we have taken 2 things. That position is we have to generate the position encoding for a second position. Okay, you can generate for a first position, second position, third position, and fourth position if you are using the 4 words. Okay, so there will be 4 positions. So let's generate for a position second. Now embedding dimension is 4, so we have to compute 4 values now for a second position, because for each word it will generate a 4 length embedding. Look at here, because it's our encoding size. Encoding is 3 words, then same position encoding will be generated. If it's a 4, then same 4 word encoding will be generated. Now in this case, dimension is 4, so we have to generate 4 values. Okay, those 4 values will be generated with the 2 values only, because we have for I equals to 0, we can generate 2, from 1 from sine and 1 from cos. If I value is 0, then it will be 0th position. I equals to 1, it becomes 1. That is second 2 comma 0, it becomes 2 comma 0, it becomes 2 comma 1. And if we are putting I equals to 1, then it will becomes 2 comma 2, and it will become 2 comma 3. How it has been done? If we have put I equals to 0, position is fixed, it is 2. So it becomes 2 comma 2 into 0. So it becomes 2 0. It's become 2 comma 2 into 0 plus 1. So 0 plus 1, it becomes 1. So it becomes 2 0 2 1. Then if we are putting I equals to 1, then it becomes 2 comma 2 into 1. So 2 comma 2, 2 comma 2 into 1 plus 1, 2 comma 3. So total 4 values we are getting, and those 4 values basically it will give you the position encoding for the second position. For second position. Now how? For 0, let's say for I equals to 0, we have to calculate. So it becomes 2 comma 0 and 2 comma 1. It's for odd position, even position. It's for odd position. So we are using sine 2 divided by 10,000 power 0. Why? Because 2 into 0, it will be 0 divided by d, value is 4. So it is nothing but it's sine 2. The value this will be sine 2. So sine 2 is nothing but it is 0.9093. For first position, for 2 comma 1, it becomes 2 divided by that. Look at here, the I value is 0, because we have to use I na. So I value is 0, although we are writing 1 here, but the value in the formula it is just 2i. Okay, it is not 2i plus 1. So 2i, it becomes 0 divided by 4. So it will be nothing but it's cos 2. The value will be minus 4.161. Okay, we have taken I equals to 1. Now let's talk about I equals to, we have taken I equals to 0. Now let's talk about I equals to 1. We are putting same formula. Now I equals to 1, it will become 2 comma 2, 2 comma 3. Now it will become 2 divided by 10,000. It's a 2i. Okay, 2 into I value is 1. So 2 into I, it becomes 2 into 1, 1. sorry, 2 into 1, 2 divided by 4. So 2 divided by 4. Okay, and here also it will become 2 divided by 4. So it becomes 2 divided by, look at here, it's a root over 10,000. Okay, so it becomes 100. It's a root over 10. 1 by 2 is root over 10,000, na? So it becomes 100. So it becomes 2 divided by 1 by 50. Sorry, sine 1 by 50, it becomes cos 1 by 50. So value is basically, it's a sine 0.02 and cos 0.02. The values are near to 0. Sorry, for sine it is near to 0, or for cos it is near to 1. Okay, now the final position encoding vector for position 2 will be this. Similarly, we can calculate for position 1, position 2, position 3. If here we are having 4 position, na? So for position 1 we will calculate, position 2 we will calculate, position 3 will be calculated, position 4 will be calculated, and it will be of 3 vectors each. So based on that, it will generate a same matrix like a word embedding. So this is how we generate the position encoding. So it is clear to all of you how position encodings are generated. And word embeddings, you can use any method. Okay, most of the common method is a globe, we have discussed already. Okay, now let's take how matrix dimension are calculated in transformer. So basically, the transformer won't take entire sentence, won't take a single sentence at a time. Okay, what was the problem in RNN? We know na, RNN was using at t is times 0, it was taking one word. At t is times 1, it was taking another word. At t is times 2, it was taking another word. So it was processing word by word. Okay, now we know that whatever deep learning architecture we are using, it processes the information in batches. During training, it processes the information in batches. I have already discussed what is a batch means. Batch means it's a number of samples that we are going in a one pass to compute the update the weights. Okay, now in this case also, in transformer also, it will take the words in a batches. Okay, so words in a batches means it will take samples of, let's say in first sample, look at here, it is our first batch. Okay, so first batch is having 4 samples of length 4. Okay, look at here, 4 sequence length. 4 sequence length means these are the 4 sequence length, the words. Okay, it's a basically one sentence of having 4 length. Okay, so for each batch it will take number of samples. So in this case, this rows represent the number of samples. It's the sample 1, 2, 3, 4, 5. And these represent the words present in that sample. Now, what the major problem is that we have to take a matrix of samples of having same length, and it is not possible always, hai na? Because whatever words we are taking or sentence we are taking, it will be generated from some corpus, na? And that corpus won't be having same length. It means all the sentences won't be having the same length. So what we will take, how we will deal with that? So what we will do here is we will take the maximum length of sentence. Okay, and based on that, we will create the number of words, possible words present there. Now, if a sentence is falling short, it means, let us suppose that maximum in out of my 5 samples, let us the maximum length sample was having 7 words. Okay, now let's say 2 samples are falling short. Let us say in sample number 2 it is having only 3 words, and sample number 3 it is having, let's say, 5 words. So remaining 4 words will be padded to 0. That's why we are using pad. Look at here, we have used pad because our matrix requirement was that we have to use 4 length word, 4 length sentences. That's why for one word we have added padded, so that it will be perfectly matched with its batch size. Okay, so here what we understand, how if the sentence falls short from a 3 words, then 3 word will be padded. If falls short from a 2 word, then 2 word will be padded with a padding information. Padding information can be a 0 information. Okay, so this is how a first matrix will be created. So it is nothing but it's our word matrix, or we can call it sentence matrix or first batch. Now this entire matrix will be given as an input to the embedding layer. Now this embedding layer will generate the word embedding for this entire matrix. So how it will be generated? So look at here, if we are talking about this position, now this first only one column, it means it's a first word of a first sentence. So for a first word of a first sentence, it will be, look at this position. It's a first word of a first sentence. And let us say our embedding size is 3. Look at here, we are using 3 embedding size. Na? So if let us say our embedding size is 3, it means the word embeddings must be of 3 length. Okay, so look at here, it will be a 3-channel matrix. So it is a first position embedding, it is second position embedding, it is a third position embedding. So this represents the embeddings of a first word of a first sentence. This represents this, and the next in the matrix, it represents the embeddings of a second word of a first position. sorry, second word of a first sentence. It represents the embeddings of a this represents the embedding of a third word of a first sentence. So in this way, this represents the number of samples, this represents the number of word, and this represents the embedding. Okay, so the matrix will be, let's say if the embedding size is 3 and our sample size was 5, having 4 word in each samples, then the matrix will become 5 cross 4 cross 3. Okay, with the same size we have to generate the position encoding also, because for each word we have 4 position na? And for each position we have to generate 3 embeddings. Okay, so we have to generate this represent the position in embeddings encodings. Okay, here whatever how we have representing in the word embeddings in this matrix, we will represent it through position encoding. Okay, it will, the rows will represent samples, the column will represent the words position, and this z axis this axis where we are changing the channels, okay, it will represent the embeddings, or in this case it represents the encoding. Okay, so it will be the encoding for a first, this entire row, sorry, this entire from first position, from first channel, second channel, third channel, this first position will give you the position encoding of a first word of a first sentence. Okay, now this matrix has been generated, this matrix has been generated. Okay, now in this operation what happens, the element wise addition will be happened. This position will be added to this position will be added to this position will be added to this position. So ultimately the resultant embedding vector, okay, it will be having the same dimension, 5 cross 4 cross 3, because we have added these two. It is nothing but just a matrix element wise addition. So it is clear how matrix representation has been generated for a batch of a sentence. Okay, up to this point it is clear. Now let's see how it happens. Okay, now it's our encoding part, it's encoder. Now look at here, in our encoder decoder stack we can have a multiple encoder, we can have a multiple decoder. Now we will see how this matrix passes through the encoder channels, or sorry, encoder part and decoder part. Now this is what it's basically the first portion. Okay, it is nothing but it's the output of our encoding. Now in this case, look at here how it has been generated. Just a second. It is the first embedding, this is the first embedding, this will be given as an input to an encoder. Okay, this will be given as an input to an encoder. Now in this case we have having multiple encoder now. So first that will be given as an input to this encoder, the encoder will process it, and whatever output it will be generated, that will be given as an input to second encoder. It will process that matrix, and whatever output it will generate will be given to the as an input to the next encoder. Now how encoder process, so what we are taking now in this case, we are considering the second encoder, in which the first encoder architecture will be same in this 3 encoder, everything will be same. Okay, just input information is different. For first encoder the input will be this matrix that we have generated. For a second encoder the output of first encoder will be given. Now look at this is the output of a first encoder that we are feeding to the encoder 2. Now in encoder 2 we will be having a self-attention layer. We will see how this self-attention work, okay, in detail. We will be having a layer normalization, we will be having a feed forward network, and we will be having another layer normalization. It's an architecture of an encoder, it will be same. These 3 encoder having same architecture. So how it does, this self-attention module will process this. Okay, how it will process, we will see the cell during the when I will explain the self-attention module. Okay, now it is having a skip connection. Whatever information we are getting here, whatever matrix it is getting here, it will be a skip connection to the output of self-attention. So it means this matrix will be passed through self-attention. Whatever output will be generated, it will be having same size matrix. Okay, now both will be added here. Whatever the initial result was this, okay, this will be skip connection. It means whatever output this attention will give, and this matrix that we already have, this both will be added. Both will be passed through a layer normalization where the features will be normalized. Then the resultant will be given to the feed forward network. Again, here it is having another skip connection. Okay, so it means the feed forward network will process this. Okay, and the output of feed forward network will be added to the input itself. Then again we have a layer normalization. After normalizing it, it will produce the output of a second encoder, and this output of a second encoder will pass as a input to the third encoder. And in some cases we can have up to 6 encoders. Okay, so this is how the encoder works. Okay, now let us see how this decoder works. It's a basically decoder side. It's a, let's say it's a decoder 1. Okay, so decoder 1 means we have already seen the transformer architecture. Okay, look at here. Just a second. Let me show you again the transformer architecture. Look at here. It's a transformer architecture. Now we can have multiple encoders, up to 6 encoders we can go. In some cases, even more. Okay, look at here. It's a decoder part. Okay, we are having decoder 1, decoder 2, and this will be generated same. Okay, we have already seen how embeddings and position encodings are generated. Okay, now let's discuss the working of a decoder. Now it's a decoder part. So here what we are getting, it is from output embedding. Na? So output embedding means our resultant. Let's say in this case, we were translating into the Spanish where de nada was there. Okay, so for de nada, it has to be a forward. So we will be having a start padding, then de nada was there, and then padding was there. From there, we have generated a matrix representation. Okay, that matrix representation will be given to the self-attention module. Okay, then there will be a skip connection again. So whatever we are giving here to the self-attention, same information will be added to the output of a self-attention. Then we are having a layer normalization. Then we are having the encoder-decoder attention. Okay, then whatever this is, na, this, look at here, this output of it, it's a 6 encoder. If we are having a 6 encoders, then the final output, last encoder's output will be given as an encoder to the, as an input to the encoder. Now it will take 2 inputs, one as a encoder input, encoder output, and another is a output from the layer normalization. Both it will process, and there will be a skip connection. Then there is again layer normalization. Then okay, it will, whatever output will be generated, it will given to the feed forward network, and again there will be a skip connection. So basically output he generated from here, the output present here, it will be given as an input, and new output will be generated. Now this old one and this new one will be added and passed to a layer normalization layer, which will generate the final output. This decoder 1 output, it will be given as an input to decoder 2. Okay, this is how the matrix will be processed within the decoder part. Now look at here, it's a basically attention module. Okay, so how attention module is basically generated. Okay, now look at here, it's a encoder side attention, it's a decoder side attention. So we have 2 attention. Now look at here, it's a self attention for encoder part, and it's a, we will be having a encoder decoder attention at a decoder part. Okay, so self attention, it works same. We have 2 types of attention. Look at here, it's a encoder decoder attention and a self attention. So we will look both. It's a self attention and it's a encoder decoder attention. Okay, look at here. Now let's try to see the self attention, how it works actually. So encoder output will be generated. Okay, that's encoder. Look at here how it has been generated. Na? Here it's the encoder 1 output. First it will be fed to the self attention, because in every encoder the starting point will be a self attention and ending point will be a layer normalization. Okay, so look at here. So it's an encoder 1, its output has been generated. Now from the output it will extract 3 values. Okay, 3 parts. This output will be converted into 3 parts. One is known as value, another one is known as key, another one is known as query. Okay, so what is a value, key, query? We will see and how it will generate it. So how it will generate it, let me discuss. So here 3 linear layers will be there. Okay, layer 1, it will be a linear layer. Layer 2, another layer will be there. Linear here, another linear layer will be there. Okay, with a different weight values. So whatever this same matrix will be passed through first linear layer and with a different weights. Now all the layers will be having different weights. Okay, so the output of this linear layer will be known as a value, and the output of a second linear layer will be known as a key, and output of a third linear layer will be known as a query. Okay, then there will be a operation, self-attention operation. We know now what is a self-attention. So self-attention means if we are known with a one word, then what next word will be? It will be the self-attention. What could it be? There will be a relationship. Now we have discussed in our first initial slide of this presentation. We have already discussed. Na? So that how self-attention will be calculated, we will discuss in the next slide. Okay. So it's during the encoder 2, the self-attention is what? How it will be calculated, we will see. Initially what happens, the matrix, same matrix will be given into as an input to 3 linear layers having different weight. The first linear layer's output will be given, will be treated as a value. Second linear layer's output will be known as a key, and third linear layer output will be known as a query. Okay, these 3 information will be passed to the self-attention, and that self-attention score will be calculated here. Okay, we will see how it will be calculated. Now, during the encoder decoder attention. Look at there, it's encoder decoder attention. So encoder decoder attention, we have two things. Now look at here, we have a self attention already there, and we have a encoder decoder attention. So we will look these two because both are present in the same decoder part. Na? So initially it's a decoder out, it's a decoder one output. Okay, in some cases we can call it it's an initial matrix if we are feeding it to decoder one. Okay, so already we have passed to a decoder one, it's a decoder output. Now it will generate three information. Again, we are using here three linear layers. The first linear layer will be placed here, second linear layer will be placed here, third linear layer will be placed here. Okay, so you know what is a linear layer? It's a nothing but it's just a basically linear operations will be there. Okay, now the first output of a first linear layer will be treated as a value, output of second linear layer will be treated as a key, and output of a third linear layer will be treated as a query. Now there will be a self attention will be calculated. Self attention is nothing but here we will be using softmax function. We will see how we will calculate. Okay, whatever output or self attention score will be generated here, that will be given as a query part to the encoder decoder attention, so that based on this encoder, okay, decoder can generate its relevant information. That's why we are taking both. Now we are considering both. Okay, it's a self attention. Self attention means the word will give attention to their inbuilt information or their self information. That's why we call it a self attention. Okay, why this is called encoder decoder attention? Because this based on the encoder information, the decoder will give attention to the output part. Okay, the decoded part. Okay, that's why we call it a encoder decoder attention. Now this is a query that we have generated from a self attention. It's a basically a self attention score that will be given as a query. Now this encoder output will be passed through two linear layers to generate value and key. Okay, now based on that, here a encoder decoder attention will be calculated. Now we will see how it will be calculated. Okay, up to this portion it is clear. If you are having any doubt, you can ask me. Up to this portion it is clear. Okay, now we have one more thing that is called multi-head attention. Okay, so how multi-head attention will be there? Now there will be multiple linear layers. Okay, so basically transfer the here the transformer cells. Okay, where each attention process, each attention processor, okay, will be having a attention head. Look at here, it's a attention head. We are having 4 parallel process, so that's why we call it a multi-head attention. Okay, how it will be done? It is not, basically we won't be having a multiple. Okay, how it will be done? It will be execute same thing parallelly for 4 times. We know how to attention has been calculated. Now look at here, it's a self attention. Okay, how it is calculated. Now assume that 4 times the same thing will be calculated parallelly, so it becomes multi-head attention. Now we are using a mask concept. We will see what masking is. Okay, masking is basically due to the padding, we have to use mask concept. So look at here, the query here, Q is the transformation represents the query as a token is trying to find relevant information. Query means all we know now. What is a query means? Query means something you put for which you want to find a relevant information. That becomes query. It means your question. So that's why this is a transformation represents query. A token is trying to find a relevant information. What is a key? Basically, key of other tokens that might be relevant to the query. So basically it will generate a key value. It will basically give you the relevant, these information might be relevant to the query part. Now the value part, the transformation represents the value or actual content that will be retrieved based on the attention score. So it will be nothing but it's basically attention. From there, attention scores will be generated, and from there the actual values will be whatever has to be transformed, it will be produced. Okay, and multi-head attention is nothing but we are having n heads. So basically n self attention will be executing parallelly. Okay, this is clear up to you. Up to this point it is clear, or if you are having any doubt you can ask me. Okay, now let's see how this attention will be calculated. So look at here, it is our your welcome pad, our embedding was there. Now from it has the same matrix will be given a query to key and value. Then from linear layer it will generate the query vector, a query matrix, key matrix, and vector matrix, value matrix. These 3 will be passed to the attention layer to calculate the attention. How attention will be calculated? Using a softmax function. Okay, so basically softmax function does what? It generates probability. So this, look at here, the probability will be generated. So how probability will be generated? For U word, it will generate all the probabilities, all the let us suppose in our, we are converting it to a, okay, we will discuss it later while discussing the output portion. Okay, so it will generate the probability softmax. Okay, how it will generate? It will multiply this q query with the transpose of k, plus it has to generate, plus add some mask. Now what is a masking? We will tell, I will discuss what is a masking. It is due to the padding. Let us suppose that due to the padding, let's suppose these are unwanted information, these are padded information, na? Then the relevant information will be present in this portion only, let us assume. Okay, then the padding, the masking will be used to restrict our decoding portion to the relevant information only. So the equation is basically, it's a q into k transpose plus mask divided by the root of embedding size. Okay, plus this value will be multiplied, and the result, it will be the probability. Okay, this is the basically how attention works. Now look at here, what is the embedding? So, and what is a masking in this case? Now look at here, we have written na, you are welcome was there. Okay, now this is the padding. Huh? Why it is padding has been generated? Because it was a 3-sentence word, na? And let us suppose that our entire words will be 4. Okay, now in this case, this is a padding. Now this is the mask. This mask represents the actual words that has to be translated. These are useless words. Okay, so in resultant will be, mask will be applied to this information. It will restrict the positive relevant information to this portion only. Rest will be omitted. Okay, this is the masking. Okay, now look at here how this masking will be done. Okay, in the output. Now let us suppose we have to predict the word 3. Let's say it's the input, me numbers is kitten. Okay, okay, the word 2, 3. For the same, we have, let's suppose for 4 words, we have to translate it to another language. The output will be 4. Now what happens in this case? Word 1, let us suppose we have generated, word 2 we have generated, word 3 we have generated. So if word 3 we have generated, then the attention will be only given from word 1, 2, 3. It won't take the 4th word. Okay, so if we have to predict the 3rd position, then it will look up to the 3rd position, not the after 3rd position. Okay, if we have to predict the 4th position, it will look 4th position, entire 4th position. If we have to predict 2nd position, then it will take attention from 1st and 2nd position. If it's a 1st position, it will take from the 1st position. So this how for a decoder, the masking will be changed. So look at here, if me has to predict, okay, so it will be take for the 1st position. For 2nd position, it will take 2 values. For 3rd position, it will take up to 3 values. For 4th position, it will take up to 4 values. So it is new masking. Okay, and based on that, the resultant mask will be generated. Okay, now this is the transformer output generation, how output will be generated. Now it's a decoder side. It will be passed to the linear, okay, linear layers. Okay, then activation will be calculated from each encoder. Look at here, from each this model, after this each, just a second, each decoder, what output is generating. Okay, so from after each decoder part, it is generating possibilities for all position. Now let us suppose, what was our word? Our word was, let's suppose, you are welcome, na? And for that we have to generate the de nada. Okay, now let us assume that in our Spanish dictionary we are having, let's suppose, 100 vocabularies. Okay, it means our vocabulary size will be 100. It means in our dictionary that is known to our transformer is having 100 Spanish word. Okay, so our transformer cannot create a new word. It has to take the word from its Spanish dictionary that is already known to our transformer. Okay, so how it will do? So basically, for 1st position, because it has to predict for a 3 word, na? Because the input size was 3, you are welcome. So it will generate 3 possible positions. Okay, and for each position, for after each softmax layer, it means for each attention. Okay, it is generate for 1st position, it will consider entire vocabulary size. Now let us suppose our vocabulary size is 1000. So it will predict the probability of possibility of having 1000 words in the 1st position. Okay, so let us suppose the first info, and it will be passed through the layers by layers. Okay, so in final layers, when the output will be chosen, how it will be chosen? Look at here, it's the vocab size. So for 1st position, let us suppose we are having 1000 words. So 1000 words will compete with each other to take the 1st position. Okay, now let us suppose the day is having the highest probability. Okay, then the day will be given as an output to the 1st position. Okay, in the 2nd position, all the 1000 words will compete with each other. Okay, to take the 2nd position, and it means our softmax layer will generate probabilities for all all words present in the vocabulary. Okay, for the second position, the probability will be generated, and the word having highest probability will be chosen for the second position. Let us say nada will be for a second position. Now for the third position, there will be no word, so it will generate bus end. Okay, because the padding or end word will be there, so there won't be any word. So the end will be having highest probability, so it will generate end. So basically, the third three position will be chosen as day, nada, end, and the output will be like this. Okay. Now this is how the target probability looks like, and this is the output probability. Now look at here. This is the vocabulary, be, nada, day, end. Okay. So we are having, let us assume that we are having 4 words in our vocabulary. So for a first position, our softmax layer will generate the probability for bino. Okay. Probability for nada, probability for day, and probability for end. Now look at here. The end is having, day is having the highest probability. So the target probability, it will become 1. So we will choose day. Okay. For a second position, look at here, nada is there. So it is now in target probability, it has been chosen as a 1. Now we are having end is having highest probability. Now it will be chosen. Now from this, the 3 position will be selected. Okay. So this is how the output looks like. Okay. Now let's see the real world use cases. So ChatGPT is a transformer based, okay, model. Okay, Google Translator is a transformer beta model. Search engines uses BERT. Okay, so these are some examples. So I'm not going to discuss deep in this because already all of you can, all are using Google Translator, search engines, and ChatGPT. Search engines mean Gemini, everything. These are search engines, na AI powered search engines. They uses BERT and this type advanced version of BERT. Okay, now the types of transformer model. These are the type of transformer model. The classification, it's a basically architecture based classification. It's a basically pre-training approach. Okay, so we have encoder only transformer model where only encoder will be present. We are having decoder only transformer model where only decoder part will be there. Okay, we can have encoder decoder transformer. Okay, now we are having, based on the training, we can have a masked language MLM, we can have an autoregressive model, and we can have a conditional transformer model. Okay, so basically look at here. So if we are using encoder only transformer, so encoding encodes input sequence for classification analysis task. So if you have to use transformer as a classifier, so you can go with the encoder only. Okay, now if you want to generate decoder only, so it's a kind of a generating text using self-attention. So it's kind of a caption generation. From one input, you have to generate text. Okay, encoder decoder, it will be like a machine translation. Okay, MLM, predict masked word using the surrounding text context. Masked word means, let us suppose I have to predict day nada. Okay, now let us suppose nada was masked. Okay, we have to predict that missing word or masked word. So we can use MLM language. Okay, auto-regressive model is there. It generates text sequentially by predicting the next word. Okay, it's a basically sequential model. And conditional transformer, it's a specific output based, given based on some condition. If we have to predict the output, then we can use conditional transformer. So these are 6 transformer model that people use. Okay, and now let's just give me a second. We will go with the part 4. Okay, we will move little bit faster because now this part 4 is just a theory. Okay, in the AI in industry 4.0 and ethics related to AI, we will move a little bit faster so that we can have at least 1 hour for a demonstration. Is it fine with all of you? Can we move faster a little bit here from? Okay, now just a second. Just a second. There was a problem. So industry 4.1, na? 4.0, also known as the 4th industrial revolution. So already you know, na? So industry, what is a 4th industry 4.0? It's a 4th revolution. Now this industry 4.0 works or looks or uses, leverages these techniques called AI, Internet of Things, IoT, big data analytics, cyber physical systems, CPS, cloud computing, and autonomous robots. So it's a basically fourth industrial revolution, which utilizes these tools, okay, to industrial process for improving their quality of manufacturing in terms of a product, in terms of a process. Okay, now let's see. It's a revolution. Okay, in 1784, Industry 1.0 was there. Okay, where mechanization, stream power, and weaving loom was generated. In Industry 2.0, it is during 1870. Okay, where mass production was there, assembly line has been generated, electrical energy was used. Okay, in 1970s around, we have Industry 3.0, which is in which automation, computer, and electronics has been taken over. Okay, in now 2000s we have Industry 4.0, and now we have Industry 4.5 also. Sorry, 5.2 also. Okay, now in this case, cyber physical system, Internet of Things, and networking are used. Okay, now in Industry 4 5.0 we have to use Gen AI and completely AI based system. Okay, now look at here, we have already discussed. Okay, now it's basically a project that we are working, how AI IoT can control the how these can be used in the industry. Okay, the project is basically we have to recycle the solar panel. This project has been funded by DST with 1.82 CR that we are working. Okay, in NIT Jamshedpur. Okay, I am a co-PI in this project. So how we are working, basically what is our target is, our target is to recycle the solar panel. Okay, now it's a basically AI controlled disassembling system where we have to use AI control mechanism or hands to deassemble the entire part of a solar cell. Okay, it's a one part. Another part is a maintenance. Okay, that is called predictive maintenance. So how predictive maintenance will be done? Look at here. Let's say it's our solar plant where all the solar cells has been arranged in a grid. Okay, so what we are using? We are using a GNS rover. Okay, where a GNS rover, we are having IoT sensor unit, camera unit, and it will be like moving in a grid to grid manner in entire day. Okay, and it will be taking pictures. It will be IoT sensor will be sensing temperature and condition, dust condition, humidity, everything from the cell. Okay, at the same time we will be analyzing the output voltage generated from the cell. Based on that, we have all the information will be directly uploaded to the cloud. Then there will be a control room. It's basically nothing but it's a big data analysis where we will be analyzing the cell performances based on its camera unit input taken from the camera unit, IoT sensors, and the voltage generated. Because it will be a kind of a multi-model which will process image, IoT sensor readings, and the voltage reading. Based on that, we will predict whether this cell is or this solar cell is damaged or it is having some issue or not. If it is having any issue or some issue, based on the GNS rover, we can generate its location and it will be given to the control. It will be flagged into the control room so that maintenance can be done. Okay, this is how this AI powered predictive maintenance will be done. Okay, now in Industry 4.0, what are the core features? First one is the interconnectivity. Look at here, it's an interconnectivity. Okay, it will be located somewhere in a distance where the sunlights will be there. It will be a control room, will be a AC room. Okay, we will be having cloud infrastructure. We will be having a GNS rover, entirely drone based monitoring system. Okay, everything will be connected through internet. Okay, so in core feature in Industry 4.0 is the interconnectivity. Second one is the automation. So automation, it means you don't need anything. Like it's automation with a robotic hand or robotic arm, you can perform the dismantling. You don't need a manual dismantling unit. Okay, then data driven decision. So based on whatever data we are getting here now, we are taking decisions. Okay, that is the core part of a 4.0. Then real-time monitoring. Here real-time monitoring will be continuous in whatever operations you are doing. Okay, we will take another live example, I will discuss. Okay, in real-time monitoring will be IoT sensors will be deployed, camera units will be deployed continuously. You will be monitoring for any mishappening or any kind of disruption. Okay, that is called real-time monitoring. And you don't need to monitor, actually the models will be trained. They will be trained to flag the like anomaly situations. Okay, then decentralized decision making. Okay, so we will be having different machines. For example, let's say if you are using some production now for steel seat production, there will be another decision making. For rolling and it's another aspect, there will be another decision making. So there will be decentralized decision making. It means there will be several control rooms. Everything will be connected through a IoT based system. Okay, and the decision will be taken for a particular area or particular task. Okay, smart products and services. So smart products and services, it means right now what we are using, the products can communicate to each other. For example, if you have weird a hand a smartwatch. Now it will be it can be connected to your, let's say, mobile app. Okay, they will be communicating with the mobile app. You can literally control everything with present within your room in a smart cities. Okay, so these are the smart product and services. Okay, then the key technologies driving optimizations. So driving optimizations means we have to optimize two things: process optimization will be there and profit optimization will be there. Okay, now look at here, we can use machine learning, AI, we can use IoT, we can use big data analytics, cloud computing, so cyber physical system and digital twins. Okay, so these are the technologies that in industry 4.2 people are using for optimization. Okay, now look at here the basic characteristics I have already discussed. Now, first one is the process optimization. So basically, what is the process optimization? Means improving the industrial workflow using smart, connected, and data-driven technologies to enhance efficiency, quality, and flexibility. How we can do that? Let's take an example. Now, let's say Tata Steel is here in Jamshedpur. I am in Jamshedpur. Okay, so they are facing one problem. Now, the problem is what? Tata Steel builds steel seats. You know now what is a steel seat? जो स्टील का चादर होता है. Okay, now you have seen the very big Haivas taking a steel seat. In one Haiva, let's say in 16-wheel Haivas, there will be only 2 steel seats. Okay, it will be of very heavy weight. Okay, now what happened? The steel seat will be generated in a conveyor belt. Okay, steel seat will be generated and will be processed through a conveyor belt. Okay, then it will be rolled and it will be transferred to the Haiva. Okay, now what happens during the steel seat making? If due to some issue there will be cracks in the edges, okay, or there will be deformities in the edges, then the steel seat is waste. Okay, they have to discard the steel seat. Now assume that steel seat has been rolled, and during the inspection, if you are finding that there is a cracks in the boundaries of the steel seat, then it will be very difficult to handle that. Now what happens? If you can find out within the belt whether the steel seat is having the edges cracked or some deformities present in the steel seat, then you can stop that process at that time, and you can basically you can optimize your process. Okay, so that steel seat won't be wasted. Okay, so how we can do that? Basically here the high shutter speed camera will be installed. The camera will be taking pictures of steel seat, continuous pictures, or we can call it a videos. So videos are nothing but pictures. It's with a frame rate. Okay, so it will be taking pictures of the steel seat. Then from the pictures of a steel seat, by applying some pre-processing, we are trying to finding the edges of a steel seat. If edges are not properly aligned, if there is a deformities and anything, then it will be monitoring the deformities, and within 12 seconds, okay, it will inform the control room that deformities has been present. You can remove the steel seat. So that is the real-time smart decision making in industry 4.2 that people are using. Okay, now we're focusing on using real-time data. In this case, we have focused on real-time data. Automation means directly that information will be generated from a decision-making system, and it will transfer the signal to the your seed generator and conveyor belt, what we call it, machine. Okay, conveyor belt based machine to stop the generating seed. Okay, and AI will continuously refine the process. So this is called process optimization. Okay, then goal of process optimization is we have to reduce the cost. Okay, now let's say steel will be wasted, then it will be very costly. Okay, now you have to take that high weighted steel seat to the blast unit, so that you can generate the melted steel. Okay, then from there you can again create the steel seat. Okay, so it will be a costly process. It will also improve the quality. Okay, increase the throughput. Okay, minimize the downtime, enhance the sustainability. So these are the goal of a process optimization. Now, how optimization happens? Using the 4 things. Monitoring. So we will do monitoring via sensor and IoT. Analysis using big data and AI. Or whatever data the sensor and IoT will be generated, it will be fed to our AI system and big data analytics system. Based on that, it will analyze and generate signals, so that you can control that unit automated or by human decision making also. And sometimes we do automated signal will be generated and the human will intervene. Okay, and you can do both. Okay, then based on the feedback you can improve your model also. So these are the basically 4 things in which optimization will be done. Now these are some key technologies. So we already discussed how IoT will be for real-time monitoring, AI machine learning, it will be for predictive analytics. Okay, cyber physical system, integration of this hardware to the software part. Then cloud computing, it's a basically centralized data storage in cloud. You don't need a physical storage, because cloud will give you high processing unit. in a internet. Okay, so that you don't need to be having a high processor at your uh, let's say your factory or whatever your warehouse or whatever your control unit. Then big data analytics is there and digital twin is there. So all of you must aware of digital twin. So digital twin is basically it's a simulator or testing, okay, in which real world scenario will be tested. Now let us suppose if we have to test, we have modified the let's say a plane architecture of a plane. Now let's say wing of a plane has been modified a little bit. Okay, now if you have to test now, then you have to literally make a plane and you have to fly it in a real world scenario. Now let's say if that fails, then there is a chance that your plane will crash and it will be a very costly. Now to do this, digital twin has been invented. The same plane will be designed in a software where it will mimic the real time simulation, so that whatever you have designed will be simulated in a real time. So it will behave just like how a real plane will behave. That is called digital twin. Okay, so major areas where optimization can be done in industry 4.2 is predictive maintenance. Okay, predictive maintenance is basically based on the sensor data and the whatever information you are available, whether it's a sensor data or camera unit or whatever things you have installed. Based on that, you can predict whether the part of your machine or your machine is going to shut down in the future or not. So it is a called predictive maintenance, so that you can be prepared. Okay, basically production scheduling, energy efficiency, supply chain optimization, quality control is there, inventory management is there, human machine collaborations is there, real time monitoring is there. These are the major area where optimization will be done. Okay, now it's a basically result of optimization in terms of a metric downtime before and after optimization. If you are using it, it has been seen that downtime was high in weekly. Okay, after optimization, AI based optimization, it has been reduced to till 60%. Maintenance cost has been reduced to 30%. Equipment of lice has been increased due to the early alert, so that you can do the maintenance early. Okay, worker efficiency, it has been proactive diagnostic. Okay, production output, it has been more consistent and higher. That has been seen. This result has been seen in industry 4.0 after AI based optimization. Okay, these are challenges, okay, in optimization. Real data related challenge. Okay, data quality that we are generating, you have to rely on the sensor. Okay, there are some cases where sensor will give you the false data. Based on false data, false alarm will be generated. So data related challenge always will be there. Technology limitations. Okay, technology limitations means there is a biasness in the AI model that you have generated. Okay, so there is a chance that it will give you a biased decision. At the same time, the initial setting cost will be very high. Okay, and scalability issue will be there, because if you have to scale it up, then you have to invest an very much high cost. Okay, process complexity is there. ROI, return of investment uncertainty is there. Whether whatever you have invested in building that AI system or AI based your automation, whether you will be recovering that part or not, it is uncertain right now. Integration complexity is there. Workforce related challenge will be there. Okay, process complexity will be there. Change management will be there. These are some challenges that has been associated with the process optimization in industry 4.0. Okay, now now what is a key takeaway from AI in industry 4.0? So the key takeaway is think value, not the tech. So basically, AI intelligence is a significant component, or we can call it a catalyst of the fourth industrial revolution, but not the sole defining factor. It means we can use the tech to improve our automation or to improve our process optimization, but we cannot solely depend on the tech. That is what think about the value, not about the tech. So big areas of concern, including the increased inequality, security threats will be there. If let's suppose AI has given some false prediction, based on that the machine will be shut down something and some mishappening will be there. Okay, so it's a machine, it's mishappening. Okay, you can't control that. So there are so many security threats are there, unemployment due to the automation, and challenges to identity and community. So these are some concern areas. So that we have to rely on the tech, but we don't have to completely dependent on the tech. That is the key takeaway from the industry 4.0. Okay, now let's dive into the part 5, that is ethical, social, and future of AI. Okay, so we will see just few areas, what ethical challenges and what are, then we will go for a live demonstration. Okay, now the ethical issue in artificial intelligence. First one is the lack of transparency. So what is the lack of transparency is that basically in most of the cases, AI is a black box. Okay. So AI is a black box, and let's suppose if we are using transformer model. Now in this, let's say in gen case, na, or generative adversarial network case, you don't know na, which vector position has been changed, and based on the output will be generated. It's a completely black box. Random iteration will be going on based on that latent vector will be changed and output will be generated. So you can't, basically there will be no transparency. You don't know how the output has been generated in most of the cases. That's why people are right now working on an explainable AI, okay, so that the whatever output has been generated can be explained. Okay, so it is very difficult to know how that AI has been taken the decision, okay, or generated that something. Based on that, another is bias and discrimination. Now AI completely depends on a data. Now let us suppose AI model has been trained to predict, or so let's say to differentiate between, let's call it, let's say just take a horse and a elephant. Okay, we have trained, it's a basic example. Now just we have trained a model to differentiate between horse and elephant. Now suppose you will be given an input, you are giving a dog as a input feature, then AI will tell whether it's a horse or dog. Okay, so let's say a dog is resembling little bit more to the horse as compared to the elephant, then AI will say that no, it is not dog, it is horse, because I know two things only, horse and dog, horse and elephant. So I will tell whether it's a horse or what, elephant. So that is biasness will be there. So whatever data it has been trained, it will give decision based on the biased data. Now let us suppose AI has been trained on a particularly biased data. Let's say in that case a horse and elephant is there, and it has been trained with a 90% at time 90% elephant data. Then there is a chance that most of the cases AI will tell that whatever information input you are getting, it will give it as a elephant. Okay, the biasness will be there. Okay, accountability and responsibility. Okay, determining who is responsible for decision made by AI, it is an ethical issue. Okay, based on AI decision, there can be a mishappening. So who will be responsible for that mishappening? We don't know. It's a basically ethical issue. Developer will be the responsible person, or user will be the responsible person, or organization that he is using that AI will be our responsible person. It is a ethical issue. Okay, responsibility and accountability is not fixed. Now there is a privacy intrusion based on AI, because right now everywhere cameras has been installed now. So AI based surveillance can be done. So it is basically it will be a data harvesting. You have lots of camera installed everywhere, and you can literally harvest the data, and you can take everyone's footage, and due to the generative AI, you can literally generate the same person doing a different thing. Okay, even without your consent. Okay, let us suppose a person is, let's say, picking something from a, let's say, a cart. Let's say he is buying a samosa. Literally from that footage, someone can create another footage that a person is picking up a bomb. Okay, that is a major challenge. Now these are the four fairness and biasness cases in AI. First, bias in training data. If whatever training data we are feeding, that training data is biased, okay, then your decision will be biased. Okay, that is a major problem. So getting a good training data is always be challenging. Okay, getting bias-free training data, it's always be a challenging task, especially in case of a healthcare sector. Let us suppose if you have to design an AI-based model to detect a brain tumor. Now, let's say if you are taking MRI images. Now, if you are taking 1,000 samples, now there is a chances that 900 samples will be having no tumor. Only 100 samples will be having tumor of a different grade. So data is already biased. Now, we in 90% type case data that we have trained is having no tumor. Okay, so to get a unbiased data, it is a very challenging task. Okay, second is a lack of diversity in AI teams. Okay, it's basically homogeneous development teams may unintentionally overlook bias issue or fail to test models across diverse population. Now what happens, whatever team has been generating a AI model, they will be kind of a same group, they belongs to same group, and they are working on a same type of problem always. So there is a chance that they will overlook some biasness. That is a major drawback. Okay, if a AI system will be developed by one group and it will be validated by another group, then there is a chance that other group may look to the whatever problems are available or problems has been associated with the developed AI model. Okay, that is the issue. Then we have a disparate impact. Okay, even When not explicitly biased, AI outcomes may disproportionality disadvantage to a specific group, raising a concern about the fairness. Unintentionally, AI can generate a biased decision. Then fairness in auditing. Emerging frameworks and tools aim to audit algorithm for fairness metrics. So there is no fairness auditing. We don't have any software that can audit the fairness of a model. Whether a model is generating a biased decision or not, we can't tell. There is no model or framework that can audit the correctness of AI model. Just we are having some matrices. Based on that matrices, we are saying that AI is good or not. Okay, that is a major problem. Now, privacy concern, mass data, due to the video surveillance, mass data collection is going on. Okay, facial recognitions are going on. Everybody is using facial recognition. Let's suppose if everybody is using, most of the people are now, let's say, using Apple phone, na? And there is a face recognition. Who might knows that whatever face has been recognized will be stored in the Apple cloud. Okay, there is a chance that Apple can store all the data. Then data breach and misuses. We have seen so many data breaches. Facebook have leaked the data. There are so many data breaches. Okay, lack of regulatory standards. How AI will be regulated, how data privacy has been done. It is right now, there is no gold standard for it. That is a concern. Okay, now due to that, explainable AI is coming, that is XAI. Okay, so that the black box problem can be solved. So black box problem is how AI is making decision. We don't know, na? So the explainable AI focuses on that. It will try to give a transparent decision making system. Why explainable AI matters? Because you know, na, how AI is making decision, then you will be having trust on the AI. That is the major issue. Techniques for explainability. Right now, there are some fixed technique, but it is not completely explainable. We are having SAP, LIME, we are having heat map generation. Okay, so but these are little bit explainable AI, but completely how they are making decisions, we don't know. From SAP analysis, just we can know that which feature is responsible for a decision. Let's suppose from an image you have generated 100 feature, na? Out of that 100 feature, it will tell which feature has been contributed how much to give the decision. This type of explainability is there, but complete explainability is not present. Regulatory and ethical demands. Okay, so XAI is increasingly required by regulators and ethics board to ensure fairness. Okay, these are some things that is associated with explainable AI. Now, AI and job displacement. So basically, automation and routine jobs will be displaced because continuous automations are going on and AI-based automations are going on. Okay, so if to operate AI system, you need one or two. So there is a high chance that automation and routine job may go on. Okay, but reskilling and upskilling is needed. Okay, so if you are a routine worker, then if you can upskill yourself by working with a AI-based system, then you might be safe. Emergence of new roles. So based on, let's say, automation and routine job will be gone, but based on that, new jobs will be created. That AI-based job who can handle the AI-based system. Uneven impact across several sectors. There will be, if your skills is a low skill. Now let's say if you are a plumber, if you are a carpenter, then there is a very high chance that you will be at lower risk. Okay, why? Middle skill jobs will be at more risk if they are kind of a working on automation system. But till now, we can't say, because the initial setup cost of AI based system is very high and everyone cannot afford it. So it's a basically questionable thing right now. Now, advancing advancing UN sustainable development goal. So this is the UN's goal for AI based future, that health and disease prevention is there. One, education access, AI based education access is there. AI based climate and environment change will be there. How to handle the climate and environmental issue, and UN AI based good initiatives that started for focusing on equity and ethics and collaborations. These are some UN goals. Okay. Regulation and governance of AI. Lack of global standard. We don't have right now global standard of AI. Ethical principle in a law, it needed, but right now we don't have. Okay, AI act as a global model. Okay, role of public policy. So these four things we needed. Okay, in governance part. So in AI in developing countries, how AI is contributing in developing countries? Basically, it's a basically kind of a agriculture optimization. People are using drone-based agriculture optimization, drone-based fertilizer dispenser system. Okay, AI-based disease detection and prevention system. They are using AI in healthcare system. Okay, for remote diagnosis, mobile health application they are using, disease surveillance is there, continuous monitoring is there, complete health monitoring system is there, education and literacy people are using, in which AI powered system they are using. If let's say if AI powered tech has been installed in your classroom, then you can literally predict which boy is focusing more, which boy is lacking behind. You can literally do that. Okay, barriers to adaptation, but till now there are so many barriers to adopt the AI based system, like limited infrastructure. Everywhere we can't use AI, na? Because initial cost for AI setup is high. Okay, lack of local AI expertise also. These are the case of AI in developing countries. Okay, human AI collaboration, right now it is going on. Augmented intelligence. Okay, so augmented intelligence means the AI capability will be infused to the human brain, like a chip inserted in your brain, so that your your decision making capacity will be drastically enhanced. Then example, across industry, people are using AI based uh, assistants. Doctors using AI to enhance the diagnostic, journalists use it to analyze the data, designer used to generate a new ideas. Okay, trust and transparency is there, skill complementary is there. These are some human AI collaborations. Okay, future of AI and AI beyond. So first, from narrow to AGI we have already going on. So what is a narrow AI? You need to understand. Narrow AI is a AI which can capable of doing one task perfectly. Okay, let us suppose if you have designed a AI to check whether there will be rain or not based on the environmental condition, then AI will perfectly do it. He will perfectly predict where in next 1 hour AI or rain will be happening or not. So that is called narrow AI, AI that is mastered in doing one task only. What is a AGI? General AI we call it. Okay, so general AI is basically, it's nothing but it's a replica of a human. Then they can do multitasking. How we can do multitasking? Okay, one time I am asking, another time I am scrolling, so we can do multitask now with the same efficiency. Okay, so that is called general AI. So people are moving from AI to AGI to create a general AI, so that they can create robots. Now robot can take multiple decision at a time, and they can, based on decision, they can literally operate things. Okay, that is a AGI. Now beyond AGI, they are going with a super intelligent AI. So it is basically human symbiosis is there. It means the chip will be inserted in a human, and human brain will be enhanced to 1,000 times. That is the major focus. Okay, and China has already started to design brain AI. Okay, that is the goal. Now AI risk and existence already we have discussed. There is a chance that automation weaponization will be there. If let's say if super intelligent AI can come, then literally he can create weapon, and it will be a dangerous and lethal situation for the entire world. Super intelligent alignment problem, uncontrolled feedback loops, concentration of a power at a particular control of power will now with AI, because he can literally operate everything. Okay, these are the factors. Now in 2020, what will be the possibilities? Healthcare transformation will be there. It means that healthcare will be completely assisted with AI based system. Workforce reconfiguration will be there. AI based entire automation system will be there, so entire routine job will be, there is a chance that dislocated. Okay, or based on that new jobs will be created. AI based job will be, governance and regulation will be definitely come to operate the AI based system. AI will be seen everywhere. These are the prediction of AI in 2023. Sorry, 2030. Now, futuristic vision of AI, that is in 2050, that is human AI symbiosis, that is super intelligent AI, where the AI chip or AI band will be inserted or attached with a human brain, so that it will increase the capability of human brain many times. Self-improving system will be there. Self-improving system will be, it's a kind of a reinforcement, advanced version of a reinforcement learning, where a system will learn from the environment itself, and it will improve itself continuously. Governance policy will be definitely come, and ethical shift will be there. These are the futuristic vision. These are some open research challenge in AI. That is, robustness and safety is always there. How to create a robust bias-free system? It is a difficult. Explainability and interpretability is current trend. People are working in an explainable and interpretable AI. Ethical alignment is also an open challenge right now, and generalization and transfer learning is an open challenge. How one model can be generalized into different type of problem? That is another open challenge question right now. Now, we will stop here. Okay. Up to this portion, it is clear to all of you, so that we can start with a live demonstration of a capstone project. Up to this portion, if you are having any doubt, if any query you want to ask, you can ask me. Or shall we start the designing on AI system or AI based model to predict something or to make some decision? Can anyone tell me? Can we start that live demonstration? We will see how AI based system can be implemented to predict something. Okay, give me a second. Just a second. I am so first thing. Look at here. So in which we will work. Okay. So how to literally you can develop a AI based solution very efficiently in a very small time. We will see. So first, before going into the implementation, first we need to know what kind of AI system are publicly available and ready to use. We call it a transfer learning. Transfer learning method. It means a model has been trained on something. Okay, we will just modify that model a little bit so that it can be useful for your task. Now let us suppose there is a model called VGG16 DenseNet. Okay, let us suppose that DenseNet, let's say, I will show you how many models are there. Just type Kira's application and look at here, a site will be open. Just you have to click on the Kira's application. Look at here, these many transfer learning models are available and ready to use. It means literally you have exception, VGG16, VGG19, ResNet 50, ResNet 50 version 2, so many versions. If you want to build a system that will be a lightweight, then you can go with a mobile net. Look at here, mobile net version will be there. Look at here, two versions are mobile net here. This first thing is size. Look at here, the size is very little, just 16 MB required, just 14 MB required. If you have to, if there is a no hardware restriction, then you can literally go NASNet large model, or you can go efficient net version. Look at here, efficient net final version. It is having 479 MB data. And look at here, this is the top accuracy. So how top accuracy has been calculated? All these models that are available here, this all models are ready to use. Just 2 lines of code you have to change, and you can literally implement every model. Okay, we will see how it can do. Okay, now what are the top accuracy? So top accuracy, all this model has been trained to differentiate image into 1,000 classes. All this model has been trained on an ImageNet dataset. So look at here, what is the ImageNet dataset? Look at here, this is the ImageNet dataset. It is having 1,000 classes. Okay, so it is having, sorry, right now it is having 14 million images and 21,000 categories. It means a model, assume that a AI model has been already trained on a 14 million images, okay, to differentiate between 21,000 classes. So what will be the efficiency of that model? Okay, so this is called transfer learning. How we will use the already trained model. Those model has been trained on this data. Okay, this 21,000 categories of 40 million data. It will be trained. Okay, and it will be the same learning. Whatever it has learned, it will be used for another task. So what is the transfer learning? Let me take you one example. Very simple example. Just a second. Give me 1 second. Let me take your image. Look at here. It's an image. We have an ImageNet dataset. You can see here. Okay. We have some network is there. So ImageNet dataset, our network will be trained to classify images into 21,000 category. So what we will do, this trained model we will utilize to predict this skin lesion images. So how we will do, the entire model will be having 2 parts. This initial part is known as a feature extractor, and the last part is known as a classifier. So we will take the feature extractor part as it is, the trained part, okay, and we will modify the last part, that is called classifier part, so that it will be capable of handling the 4 classes or 3 classes, whatever our task is. Okay, that is what transfer learning looks, and we will try to implement that transfer learning. So let's say transfer learning, in VGG. First, we will implement VGG 16. That is Visual Geometry Group has developed a 16-layer model. So look at here, it's the architecture of VGG 16. VGG 16 is having 16 layers. Then there are two fully connected layers. So up to this portion, up to from starting to last two layers we have two left. Okay, these are the fully connected layers. And up to this pooling layer, it is called feature extractor, and this is called fully connected layer. So what we will do, we will take this feature extractor part from the trained VGG16 model that is available, which has been trained on a thousands to 21,000 classes of 14 million images. Okay, we will take it as it is. Okay, and we will customize this last layer so that we will change it to our task. This is our task. Okay, so how we will do that? We will take it, and it's your choice. Now you can literally retrain entire architecture. So when you will perform retraining of entire architecture, it will take so much time. So how we do it? We know now. If let us assume that there is a person who can try to categorize a image into 21,000 classes. Okay, and you want to train him to categorize two different images. So for him, it will be very easy to differentiate two images now, because he know how to categorize 21,000 classes. So he know how to differentiate features so that category will be different. Okay, so for him, it will be a very easy task to differentiate two or three classes. So our task is that we will take a trained model which is having a capability of categorizing an image into 21,000 classes, and we will retrain it to our characterize in some few classes based on our requirement. Okay, so it know how to extract feature, how to categorize them. So we are using its previous learning. So what we will do, we will freeze these layers. Freeze this layer means when we will do training of this network, we won't train this layer, because we know now these layers already know how to extract features. From 21,000 classes, it is extracting features. So these layers are perfect. Okay, so we don't hit these layers, we don't train these layers, we will freeze it. Just few layers from the bottom we will try to change so that this model will be adapted to our task. That is our task we will do. Okay, now let's say how we will do it. Okay, you understand now what we have to do. Okay, so let's start. So from here, first we will start with the VGG16 network. You can go with the exception, VGG19, ResNet 50. There are so many layers. So let's start with the coding with the VGG16. Okay, so how VGG16 will be coded? Let's say if you don't have any computing unit in your laptop is saying, let's say only 8 GB RAM. Okay, then also you can go do it. Okay, so how you can do it? Just you have to use the collaboratory. So look at here, I have opened my Gmail account. From here, you have to just click on the drive section. Just click the drive. Now you don't need your Gmail anymore. Okay, so my drive has been open. Okay, now in this drive, you have to integrate something. Okay, so look at here. Just click on the new. Okay, just go to the more app. Okay, now here you will get this option, Google Collaboratory. If the Google Collaboratory is installed in your drive, if it is not installed, you might not find here. Okay, so for that, what you will need to do, you need to connect more app. Okay, you need to click here. So you will get a window. Look at here. It will take few seconds. It depends on the internet connectivity. So this type of window you will get. Okay, in search app, you have to write collaboratory. Sorry. Collaboratory. No? Look at here. It will give you this. It has having translator. You have a document translator. It is having image to video, text to video generator. So you have to install. Just click here like this. Okay, I have already installed now. So that's why it is showing there is no install button. So when you click here, the collaboratory will be already installed to your drive. Okay, then if drive it has been started, the drive has been done now, then you can start with a coding in a Google Drive, a Google Collaboratory. How you can do it? Now let's say I will show you. Now let's say if I have to work on I'm taking a folder. Now let's say this is my folder. In this folder, I want to create a collaboratory. Now let's just what I have to do. I have to click on a Google Collaboratory. Okay, it will ask you create and share. Just click on create and share. it will create a Google Collaboratory page. Now look at here. Literally, Gemini has been integrated. For Gemini, if you want to ask him to write a code, it will start writing. Okay. Now we don't need Gemini because we have to work on here. Now, if you want to change this,
Sir, can we just from where you started this particular session, this particular collaboratory?
just I have started. Look at here. Just I have gone to a folder in my drive. Okay. The drive is your Google Drive. Okay. In Drive, you have to click this new option. Okay. In this new option, there will be more section. Just go to the Google Collaboratory. Now, let's say if in your case, Google Collaboratory is not showing. In that case, you need to click on the Connect More Apps. Then it will pop up a window. Okay. Here you have to type Collaboratory. Okay. Then this Collaboratory option will be there and you have to install it. Just click on the install, automatically it will be installed. You don't need to do anything. Okay. Once it has been installed, then you will get this option, this Google Collaboratory option. Just you have to click it. Once you click it, it will open a Collaboratory page. So it's basically a Collaboratory window, or we will call it it's a dynamic runtime window that a Google will offer you, where you can literally code on Python and R. Okay. And if you want to name it, let's say in this case, I am naming it as a test run. So I have written it. So whatever name you can write, okay, it will take that name. Now, how to configure this setting? Okay, everything will be there. To configure how the working environment of this, you need to click on this connect option. So here you will get multiple options. Now in this case, I have just dragged down it. Click on the change runtime. In change runtime, if you are using Python, then select Python. If you are using R and Julia, select R and Julia. I used to work on Python, so I am selecting Python. Now, if you have to do general processing task, let's say it's a computation-based task and normal processing task, so click on a CPU. Okay. Now, let's say if you are working on a differential equation type of thing, so many equations and huge number of calculations are there, then go for T4 GPU. Now, let's say if you are working on an AI-based system, then select V5 Engine 1 TPU. It's a tensor processing unit specifically designed for a deep learning task. Okay, so we will select TPU. At the same time, its different versions are there. So look at here, we have to select the 2016 fourth version. It is the latest version and just you have to save it. Okay, now click on the connect. So it will connect the runtime. Okay, so it will ask you connect with the TPU. Now it will give you just a second. It takes few seconds just because it is changing the runtime. Okay, while it is changing, we will start coding. Now, since we have nothing, let's suppose in this task we are going to implement, let's say a brain tumor classification or osteoporosis detection type of thing. So let me take what type of data set I have. So this is it's a my drive folder. Okay, in my drive there is a folder that called MLDL transfer learning. Just I am checking what are availability. Now let's say I have a brain data sets already available. So we will see how to implement it. Now let's say if I have selected a brain data set 1, let me see. It is having 2 categories. We will see multi-class classification. Now let's say it is having 3 grades. So it's a grade 1 tumor, grade 2 tumor, grade 3 tumor. So okay, basically we will try to develop a model that can classify an image, MRI image, brain MRI image into whether it's a grade 1 tumor, grade 2 tumor or grade 3 tumor. So I have a available data set. So if you want to work, now in this case, it is already, okay, connecting it. Okay. Now, if you want to work on a Google Collaboratory, then first thing you need to know is that this Collaboratory is a cloud-based system. Okay. It won't run or it won't execute your local data, whatever available in your system. It won't access it. Okay. It's a net-based system. Okay. So if you want to access Collaboratory and use Collaboratory and whatever data you want to use in that Collaboratory, that data must be present in your drive. Okay, so that Collaboratory can be integrated to your drive. It won't access the local data. So your data set must be uploaded to your drive. So I have uploaded into my drive. Okay, so this is first thing. Now it has been connected. So look at here how much it is giving. Look at here. The RAM it is giving is 12.67 GB. And disk size it is giving is 113.94. This is what it is giving with a TPU engine. Okay. So it's a very efficient one. Okay, now let's start. So at first portion, what we will do, because we know now my data is available in Drive. Look at here, my Drive, the data is available, and in Collaboratory I have to access that data. So somehow I have to connect this Drive to this Collaboratory environment. I have to somehow integrate my this Drive to this environment. We will call it a mounting. Okay, we call it mounting. So what we will do here, we will mount our Drive into this Collaboratory environment. So how we will do it? Everything code, everything I will share. Okay, you have to just literally you have to click, it will run. Okay, just you need to understand how this code is working. So we will write this. So from Google Colab, we are importing our Drive, and drive.mount content.drive. So it means whatever content available in my Drive, I am trying to mount it into this Collaboratory environment and execute it. Either click on this play button, or you can literally enter shift enter. Both are working, both will work. Okay, either click on a play button or shift enter. Okay, it will ask you permission, because that we have this Collaboratory is trying to access your Drive now. So just click on the connect Drive. Now it will ask your permission, which Drive you want to connect. Just give continue option. Now after some time, you will see that your Drive will be mounted. It will take hardly a few seconds. Okay, it takes 31 seconds to mount. Now, how to check whether your data has been mounted or not? So look at here. Here folder option is giving now. Click on this file. Look at here. Drive is showing. Click on Drive. My Drive is showing. Click on My Drive. Look at here. My entire Drive is now accessible in this Collaboratory. So my Drive has been mounted into the Collaboratory. This is how we used to do. So this is the first step. Okay. So that data can be available here. We don't need to load entire data here. Okay. And data can be accessible from Drive itself. So first position done. Okay. Now the second position is I have to read the data. The data is available in this folders. Now. So let's say I have to read these 3 category of data. So for that, to read an image, you need to use OpenCV command. Okay. So that's why I am using a pip install OpenCV, because I am going to use CV2. Okay. Because I have to read image from a folder. Na? So OpenCV gives you that option. So just pip install OpenCV in Python. Earlier it was taking. Right now that update, due to some update and version update, this OpenCV is directly not working in this script. So what we used to do, first we used to install the OpenCV library in our Collaboratory. So it has been installed. Now we can use any command that is available with the OpenCV. Now look at here, for each cell, it's an interactive cell. Na? It's a first cell was there. You can literally interact. It's a second cell. So from after second cell, you can get 2 options. Text code portion, it will generate a code, and text portion, you can literally write some text which will be not executed. It will be like a comment. Okay. So I have clicked on a code. Now I have to create a function so that I can read image from the data set. Okay. So I have a folder access now. These are my folders. So for that, I have to literally retrieve images in, let's say if you are taking over this folder now, in this folder there is a 3 different folder. In each folder there are having images. So literally I want to read these images. So I need to create some function through which I can read the images. So I have created this function. I have used 2 libraries, OpenCV, CV2, and this OS we are using. Now OS is basically your routine. Okay. Now I have defined a function. It's a function definition. Look at here. The name of function is load images from a folder. I have defined this function. It's a function name. Okay. And it takes a path as a argument. Okay. So whatever path we will provide here, from that path, it will extract all the images. It will read all the images and return you 2 vectors, or we will call it a 2 array. Okay. So look at here. We have created 2 lists, image lists and image ID. Okay, why image ID we have created? Look at here. Now let's say if we are talking about this now, so we have 3 category of images now. So for first category, it's a grade 1. For second, it's grade 2. It's a grade 3. So from first folder, if I am reading all the images, so I will assign them a image ID. Image ID means whether they are belonging to grade 1, grade 2, grade 3. So it's a basically label information. So if we are, how we can label it? Now let us suppose it's a grade 1. So we can assign label 0 to them. If it's a grade 2, we can assign 1 tag to them. If it's a grade 3, we can assign label 2 to them. So when I am reading from grade 1, so I will assign a label information to them. That is called image ID. That is 0 label. It means that if we are seeing 0, it means we will be definite that it's from grade 1. Okay. So that's why we have created 2 list. One, it will retrieve all the images one by one. For first image, it will generate label 0. For second image, generate label 0. So this type of things. Okay. Now, how entire images will be read? Look at here. We have taken file name. For a file name in OS list directory. So which folder we will provide? Let's suppose I have provided the path of grade 1 folder. So based on that folder path, it will generate the directory list. Okay. In directory list, it will list out all the file names present within that folder. In this case, let us suppose the files are this 1, 2, 3, 4, 5, 6, 7 TIF. Literally, it will list out all these file names. Okay. So from that file names available in the list directory, okay, we are accessing one file at a time. So for all the files present in os.list directory. So what we are doing, we are printing file name. So we will print file name so that you can literally visualize which data we are reading. Okay. So it will print file name. Once file name we will got. Okay. Then we are generating the path to access that file, because to access this one file at a time, we need literally path of this file from this collaboratory. And to accessing all the files, it will be a very tedious task to access every file one by one. So we have created a loop system. So already the folder path has been provided to the argument. So with that folder, we are just adding or concatenating the file name. So basically how it is doing, so till this grade 1 folder path is available. Now we are reading this file sequentially. If it is 1.tif, then with this folder path, we are adding this name so that it will be a path for this accessing this image. Okay, so that's how it has been created. Now, since we are using VGG16, we are going to implement VGG16. So VGG16 works on a specific manner, a specific size. Image must be of size 224 cross 224. That's why we are resizing the whatever image we have read. Whatever image we have read here, we are resizing it to 224 cross 224. Okay. Then if the image is not present in this case, if image is not none, it means not none means whatever image we have read here, it is not a none. It means there is some images. So what we are doing in image list, look at here, appending that particular image. If the first image has been read, then it will be appended to the image list. At the same time, at image ID, we are appending 0 because we are reading from the first folder. And first folder is basically it's a from first folder, it is our what 0 grade 1. So we are assigning a label 0 to them. And this file, this will return 2 information, one images list and their corresponding ID. So basically it's a training, it's a basically image and its corresponding labels. So this is how this function has been designed. And this one function is sufficient for all. Okay, look at here how it will be done. So now let's say I have executed. So my function has been executed. Now I have to use this function to read the images. Okay, so how I can do it? So for that, I need to call this function. So this function, we will call this function. Okay, we will pass folder path, and in return, we will capture image and image ID into 2 variables. So look at here. I have created G1 images. So it represents grade 1 image. I have created grade 1 label. So images, what it is returning, this images will be stored in G1 image. The labels it is returning, it will be stored in G1 label. Okay, and load image from folder, it's nothing but it's our folder name. It's our function name, load image from the folder. And what we are providing is a just path of your first folder. Now the question is how to get the path of your first folder. It is very easy. Now look, click on this, whatever folder option is there. Now you will get this option, click on drive, click on my drive. Now navigate to that folder. In this case, it is present in MLDL transfer learning. Now look at here. Now we have to work on a brain data set 2. Click on here. It will be having 3 folders. Now either you can right click here or you can click on these 3 dots. Okay. If you are doing right click, then look at here, copy path option is there. Now let's say if you are not right clicking, you can click on the 3 dots. It will give you the copy path. Just click on the copy path. Now look at here what copy path does. Look at here. It will give you the path of your folder. Okay, so this is how you have to copy the path. Simply whatever you have copied here, you have to just put it into the within the double inverted comma. Okay, now it has been done. Now let's execute it. Look at here, it is reading all the image present in the grade 1 folder. Okay, there is a chance that it might not read it sequentially. It will just read it like how it is present in the dictionary order. So look at it, it might take few seconds to read. It will read all the images. Okay, so for first folder we have done. Okay, while it is reading, now we have to change the function now to read second folder. What we need to update? Just we need to change this append ID to 0 to 1. So that because we are reading now from the grade 2 folder now, so we have to change the label from 0 to 1 so that it can reflect the second label, or it can reflect the second category of image. Now look at everything is same, just I have changed it to 1. Now execute it, it will take few seconds. Now again we have to use the same file. We will be using same command. This same command we will be using, but we are changing just two variables. Now from grade 1 image I will write it grade 2 image and grade 2 label. Everything will be same, but the path will be now for the grade 2 folder. Look at here, earlier it was for grade 1 folder, now it is for grade 2 folder. Look at here, it was grade 1, now we have changed it to grade 2. It will take few seconds while it is loading all the images. What we need to do, we need to create the function for the third, to read third from the third folder. Everything will be same, just we have changed the label to 2. So label 0 means it is the image is from grade 1 category. If label 1 is there, is the image is from grade 2 category, and is label 2 is there, image is from the grade 3 category. It is just that thing. Okay, once it will be done, we will execute it. It will take few seconds. Up to this point, it is clear to all of you. If you are having any doubt, you can ask me. Up to this point, it is clear. If you are having any doubt, you can ask me. Okay, difficult to read. Okay, just a second. Let me. Now it is visible. Now it is visible to all of you. Okay. Now all the images has been read. Now let's start. Now just we are executing the second folder. It will take 0 seconds. Now now we will be using same function with a, look at here, just I have changed this G1 to G2 to G3. Here we have written G3, and here we have passed grade 3. Now in this case, let's say if I am not printing the file name, then if you omit this, let's say in this case I have eliminated that print file name, then the image it will read, but it won't print the file name. It will take few seconds to read that. In this case, all the image name has been printed, these image has been read. Okay, but in this case, it won't print the image name. Just it will execute it, and simply it will load whatever, read all the images. It will put it into the G3 image, and IDs it will put into the G3 labels. It will take few seconds to read. Okay. So once it has been done, now image we are reading, it will be in list format. Okay, because append was in a list command, so it will be in list format. Okay, and we can't do pre-processing on list operation due to the list is not that much mutable. Okay, that's why. So what we do is we try to convert it to a array representation. So whatever image we have read and IDs we have read that are in the list format, in the first step we are going to it while it is executing, we will do our next task. Okay, now image has been read. Okay, now so what we will do, we will simply convert all the images into a list representation. Look at here. So how we have done, Just I have imported numpy as np, and we are using as array function, where we have passed grade 1 label. And now this label, it was earlier list representation. Now it will convert it to a array representation. Now this G1 label is a array form. Okay. Now, if you want to print the shape of this G1 label, you can literally print it. Right dot shape. It will give you the shape. Look at here. We are having in grade 1, we are having 648 images and 648 labels. Okay. So once it has been done, for all we have to do the same. For grade 2 label, grade 3 label, we have to do same. Okay. Just a second. It's grade 2 label. Enter for grade 3 label. We have to write grade 3. Grade 3. So everything will be printed. Now, if you try to print the shape of the label, dot shape, it will be 2. Look at here. We are having 136 total. Just a second. Grade 2, grade 3. Okay. Look at here. We are from G3. We are having 867, and for G2 we are having 1336 images. So this is the shape information. So the shape label has been done for the it has been done for the labels. Now we are having image list. So we are having 3 image list, na? G1 image list, G2 image list, G3 image list. Okay, in G1 image, G2 image, G3 image, we are now converting it to array representation. So we have used another variable G1 image array in the name of this. Okay, just execute it. So it will convert the entire image list that we have generated and label list that we have generated to a array representation. Now literally you can check the array representation. So it will give you this view of, let's say if I am checking the G1 image array, then it will give you the array representation of all them. You can't read it because it is not showing. It is just showing the information of array. Okay. The image is now in the array representation. Up to this point, it is clear. Now my data, that is label as well as images, both are available in a array format. Okay. So now what we need to do is, if you want to print the how many images are available in all 3 categories, you can print by putting the shape information. Look at here, G1 shape, G2 shape, G3 shape. Literally, we were having 648 images in G1 of having size 224 cross 224. In cross 3, it's RGB image. Then we are having 1336 image in G2 and 867 images in G3. Okay, once it has been done, then what we need to do is we need to merge this, because we are having 3 different image folders or arrays. Now we will try to create one single array so that we can do training and testing split. Okay, so how to concatenate? So basically you have to use np.concatenate operation. Look at here, merged image we have created. Now we are using np.concatenate, where we are passing all the 3 arrays, G1 arrays, G2 arrays, G3 arrays. Now we have put axis equals to 0 or 1. The value will be 0 or 1. Now what is 0 means? So 0 means assume that you are in x axis. The first image will be put here, second image will be just after, third image will be just after. It is what, like keeping G1 images in first pile, followed by second G2 images in the second pile, followed by G3 images in the third pile. So assume that in x axis we are putting all the G1 images initially, then after G2 images, then after G3 images. If its axis is 1, then it will be in y axis. So we have to arrange all the images sequentially. That's why I have kept axis equals to 0. Now it will generate the merge image. Okay. Now if you want to print the size of merge image, it will be like combination of all these 3. Look at here, it will be having total 2,851 images. It's basically nothing but it's summation of all 3. So same way, we have merged image we have created, and merge label we need to create. Okay, to create merge label, so we are merging, concatenating all the labels G1, G2, G3. order will be same. Okay, if you have kept in G1 in the initial, G2 will be then, G3 then in the same order you have to keep the labels also, so that it will be one-to-one mapping. Okay, now you will be having the merge label. Now let's say if you try to print the shape, it will be having same shape like this with one dimension only. Look at here, total we are having 258 labels for 250, sorry, 2851 labels for 2851 images. That is what we are having. So one, it is has been done. Then now we have to work on the training and testing portion. Okay, so basically the images has been now in one single folder, or we can call it a single array, that is a merge image, and we are having a merge label keeping all the labels of images. Okay, now my data is ready. Okay, now I have to divide this merge image into two part, training part and testing part. Okay, or validation part. At the same time, the merge label will be divided into also two part, merge training and testing, or training and validation part. So for that we need to use some functions from a TensorFlow. Okay, so we need to install the TensorFlow. So that's why I am installing TensorFlow here, because I am going to use TensorFlow operations, deep learning from using TensorFlow, that I am going to use. So it will take few seconds. It took 13 seconds. Okay, so up to this point it is clear. If you are having any doubt at any point, you can ask me. Okay, now before dividing it, we need to do one more thing. These are just array representation. These labels are these labels are in it, if you want to print this look at here, if you want to print this, look at here, it will be like just 0 and 1 values. Look at here, for grade 1 it is 0, for grade 2 it will be 1, and grade 3 it will be 2. It has been aligned like this. Now we will change it to one hot encoding. Why one hot encoding? Because we have to, ultimately probability will be generated based on the probability, the prediction will be true positive, true negative, false positive, false negative prediction will be done. Okay, so that probability will be multiplied with the one hot encoding. So one hot encoding we have already known. You have seen what is one hot encoding. So one hot encoding means if it is a 0 position so, and we are having 3 values. Okay, look at here. Now let's say right, if it's a 0 position, it means it is showing grade 0 okay, so how we will represent it? Like this. One hot encoding means it will be like this vector. Okay, where the first position will be 1, rest position will be 0. So one hot encoding, you understand now, one position will be 1, rest will be 0. So we are having 3 categories, okay, in which one category is true, and that category position is 0 position. So it will denote the first 0, grade 1. Okay, now let's say for grade 2, it will be become 0, it will become 1, and for grade 3 it will become 0 and it will become 1. So this is how we need to convert this label to a one hot encoding. Okay, so how we can do it? So using TensorFlow command. Okay, that command I will show. So from TensorFlow Keras utilities, we are imputing 2 categorical. So it means from it will be converted the array information to a categorical information. We call it a categorical information, one hot encoded information. Okay, so we have to define the number of classes. In this case, it is number of classes is 3. So it will create a 3 vector representation. In this case, it's a 3 element vector. Okay, so while number of classes is 3, so it will be 3 categorical. Okay, now label final we have generated, where we have converted to, look at here, whatever merge label is there, it has been converted to a categorical data with the number of classes equals to 3. Okay, then it will print the final label. Look at here. Now it will take a few seconds. It will take few seconds. Up to this point, it is clear. If you are having any doubt, you can ask me. Now look at here. Now it has been changed. For class category 1, look at here. The first position is 1, rest is 0. For category 3, the first position is 0, second position is 0, third position is 1. So this is how the one-hot encoding has been done and categorical data has been changed. So once the data label has been changed into categorical information, now our data is ready. Okay, now we can perform the training testing split. Now let us find how to do it. So we need to use this function. That function is import sklearn model selection. We are importing model selection from sklearn, and we are using model selection train test split function. This train test split function will give you 4 output, and it will take 2 necessary input information. These 2 arguments are necessary. Rest of the arguments are optional. Okay, these 2 are optional. We will see how we can select it. So what 2 options are compulsory, or information are compulsory? That is image and their corresponding label. In this case, we are having 2851 images, and there 2051 and 2851 labels are there. These are compulsory information. From this image, it will generate training and testing image, and from label, it will generate training and testing labels. So from these 2 information, it will generate 4: training image set, testing image set, training image label, or testing image label. Okay. Now here, these 2 information are, we call it a optional information. Here, test size. So how you want to do the split? If you have to define the test size equals to 20, then the 20% of images will be given to the test sample. Rest 80% of images will be given to the training sample. This is what it means. Okay. If you omit this, you don't put this now. So by default, it takes 2/3 and 1/3. 2/3 information will be given to the training sample, and 1/3 information will be given to the testing sample. Now, in this case, let's say if I am selecting it as a 10, 0.1, it means it's a 10%. So 10% of images will be given to the testing information. Rest 80% will be given to the training. Okay. Similarly, the labels will be generated. Now here comes what is a random statements. So random state, it's a basically, we call it a seed value to generate all the images. So what happens? Now let us suppose if we have provided the random state equals to 20. Now assume that it's a 20th index. Okay. Now it will randomly generate 10% of images. Okay. So that can be assigned to a X test. Okay. Now you know now in the world there is no function that can generate a random number. All random number generator are generating pseudo random number. Why? Because if anything generated from an algorithm, it can't be random. Okay. If we are using a random generator function, then it is a pseudo random. It is not a random number. It may appear like a random, but it is not random. Okay. Now what is this seed value is mean? Random state value if we are providing. So it's a basically seed value. So it will initiate your random number generator from some position. Okay. It will not definitely be second 20 position. Based on this 20 information, it will compute one position. But the 10% information it will be generated in the same sequence every time. Okay. If you will execute it many times now, then every time the random state is 30 based on 20. Okay. Based on that 20, it will in this case we have provided 30 now. So based on 30, it will try to calculate the first image that will be assigned to the testing sample. Then based on that first, it will try to find second, third, and that way it will generate 10% of images for the testing sample. Now based on the seed value, each time it will generate the same sequence of random number. So what happens? The same sequence of images will be assigned to the test size. Okay, that is the major thing. Now, if you omit this, so randomly it will select a seed value. So each time you execute it, there will be different training samples. That is the major problem. Okay. Now, why we need this random state? While till that we are executing. We need to assign this random state? Now, let us assume that you have to compare 4 models: VGG 16, VGG 19, Inception V2. Okay, DenseNet. If you want to let's say compare the performance of these 3. Now the first condition is that all the 3 or 4 model must be trained on the same samples. Okay. Now let's say if you have not provided this random state. Okay. So each time the random numbers generated will be different. So training samples will be different. So for model 1, the training sample will be different. Model 2 training sample will be different. Model 3 training samples will be different. Model 4 training sample will be different. Okay. That's why we keep the random state as we give a seed value, so that every time the training sample will be same. Now, another way is there to handle this random state. We call it a 10-fold or k-fold cross validation, where all the samples will be treated as a training samples, and all the samples will be treated as a testing sample. That is an advanced topic. We will we don't have that much time to discuss that. Okay, that's the entire different training process. Now in this case, we have already got this. We have divided the image and label into training and testing samples. Okay, now let's say if you want to print everything, na, your training samples and testing samples. So I have to print, let's say I have print X train SEP, X test SEP, label train SEP, label test SEP. Okay, so look at here. How many images was there? 2851. So 285 or 286 images has been assigned to our testing sample. Look at here, this is a testing sample, and rest images has been assigned to training sample. Here also it is same. Okay, now let's say if you make it a 70-30. Okay, now let's make it a 20, then it will be assigned 20% images to testing. So it will be more like a up to 571. It's a 20% images. So this is what this is. Okay, so up to this point it is clear how training and testing samples will be generated. If you are having any doubt up to this point, you can call me, you can ask me. It is clear? Now our model, our data is ready. It has been divided into training and testing sample. Now we need to call the model which we want to implement. Okay, so in this case we are going to implement VGG16. So look at here, I have called VGG16. So how you can call? Look at here, Kira's application, click on VGG16. Okay, here you will get VGG16 function. This is the function, how to call it. You will get everything, all the information is available how to call it. Okay, so look at here, I have called VGG16. In this case, now VGG16, we have imported VGG16. Now from Keras, we are importing an input layer so that we can create an input tensor layer. Okay, now this, look at here, this input one, basically it decides the shape of input that we used to give to the VGG16. So we know now VGG16 used to take 224 cross 224. So we have defined this input one equals to shape 224 cross 224 cross 3. So that based on this, we will create number of tensors, number of input tensor in our input layer. Okay, now we have to create the VGG16 model. How we have created? Look at here, we have created an instance of VGG16, named it a model. Okay, we have named it a model. We have called VGG16. First input tensor. Here input tensors means number of input tensors you want to create in input layer. That should be same as your shape of image. So that's why we have passed this input image input 1, which will be in this shape 224 cross 224 plus 3. Now include equals to top true, weights equals to image net. What these two things means? So for these two things means you need to see the architecture, VGG architecture. Look at here, this is a VGG16 architecture. Is it visible to all of you? Okay, so include top. These are called bottom layers. This is the input tensor unit. Okay, based on this, we have created 224 cross 224 cross 3 tensors here. Okay, or input layer here. This is called bottom layer. This is called top layer. So top layer means this last 3 layers. This is called top layer. Okay, so include top equals to true. It means we have to include all these layers. Okay, include top equals to false mean it will call up to this position. Okay, now another command was there, weights equals to image net. So if you can pass, you can omit it. If you will omit it, then it will initialize the VGG16 with a random weights. Okay, now if you are passing weights equals to image net, it means it will call a VGG16 model that is having the weights that it has been achieved after it has been trained on an ImageNet dataset. The model has been trained on an ImageNet dataset. Okay, this model has been trained, VGG16 model has been trained on an ImageNet dataset. Okay, so it will call that ImageNet dataset trained model, and whatever weight has been achieved after that training, the same weights will be initialized with this model. That's why this weights equals to ImageNet. You can keep nothing here, you can keep random here. So if you put nothing, so it will be randomly initiated. Or if you put random here, So it will be randomly initiated. Okay, if you put 0 here, so 0 weights will be assigned. Okay, so in this case, we are leveraging transfer learning. Okay, that's why we are keeping image net weights. Now let's execute it. Now, look at here, our model has been loaded. So how much? This is a VGG16 model. Okay, it has been now trained into differentiate in 1000 class. Okay, this is a parameter. How you have to calculate parameter in first class, I have already discussed. Look at here, how this value has been achieved. Now, how to calculate the parameter? Now in first layer, look at here, it's an input layer. This input layer, we are using 64 kernels. Now, so you need to see the architecture. In input layer, look at here, we are using 64 kernels. Okay, so what will be the shape of a kernel? You know, na? In VGG16, the shape of kernel will be 3 cross 3. And since it is a 3 channel, so it will be 3 cross 3 cross 3. So look at here, if you want to calculate, it will be 3 cross 3 cross 3 channel plus 1 bias. Okay, this will be the value 28 into how many filters we are using? 64 filters we are using. So just multiply with 64. You will get a same number, 1792. Look at here, it's a 1792. Now for next layer, look at here. Next layer, we are having 64 filters. Okay, but look at here, in previous layer, now the output is what? Now we have the output dimension is 64. Okay, that is the 64. Now it means the output will be, our kernel has been now changed. Now the kernel has been like this. It will be of shape 3 cross 3 cross 64 channels plus 1. Look at here, it's a 577 cross. Now in the next layer, we are having 64 filters. So it will be the 3600 is 1928. It's a 36,928. So this is how the parameters has been calculated. So look at here, we have called everything. So look at here, no total number of parameter is this 138 million parameters are there, which is untrainable parameters is 138 parameters. And to train 138 parameters, it will take hours and hours. Okay, so how we do it? We will do it by freezing. I have already told now that we will freeze the VGG feature extractor part. Look at here. It's a VGG16 architecture. Up to this portion, we will freeze, and remaining portion, we will train. Okay, so how we will do that? So to do that, we will do the freezing. Sorry, first we will change this model to a custom model because it is designed to train on 1000, classify into 1000, na? But we have to change it to our task. In this, it is classifying into 3 classes only. Okay, so we will do it. So look at how we have done. We have created a last layer variable where we are getting model.get layer fc1. Look at here, what is fc1 here? It is fc1. So output of fc1 we are selecting. So we are getting model.get layer fc1.output. So it is what output of this fc1 layer it is getting, and it will be assigned to last layer. Okay, now we have created another layer, that is a dense layer with a 512 neurons. Okay, and we have used activation function as ReLU, and the input it will take, it will be from the last layer. It means whatever output we are getting from this fc1 layer, it will not go to now this fc2 layer. It will go to this dense layer that we have created. Okay, then finally we are creating an output layer with out. We are using dense three nodes to classify into 3 categories, but activation function we are using as a softmax to predict the probabilities, to get the probabilities, and we are naming it as a output layer. And the input it will get, the output of this last one layer will be given as an input to this out layer. Finally, our custom model has been designed. We have converted this, and our custom model will be this model with the image input 1 and with output out. Look at now, let's try to print the summary. Now look at here, everything will be same. Just look at this after fc1 layer. So after fc1 layer, we have created 2 layers, dense layer and output layer with a 512 neuron and 3 parameters and 3 nodes. Okay, based on that, the number of parameters has been changed. Earlier it was 138 billions. Now it is just 138 million. Now it is 119 million. Okay, so this is how we have converted our model as per our requirement. Okay, now our model is ready to classify our image into 3 categories. Okay, but training 119 million parameters is still difficult. So what we are going to do, since we have added only 2 layers, So we will train this 2 layer. Rest all the layers will be freezed. So how we can do it? Look at here. So to do that, we are just calling custom model.layer function, where we are accessing all the layers available in our custom model. And it is going till -2. So -2, it means it is up to this portion. -2 means apart from this 2, everything will be selected. Okay. What we are doing, layer.trainable parameter, we are setting it up false. It means all these layers apart from these 2, every layers will be now, their trainable parameter will be false. It means all this layer will be now freezed. It won't be trainable. Now let's try to print the custom model somewhere. Now look at here, number of parameter is 119 million, but trainable parameter, it has been drastically reduced. It is now 2 million only. Look at here, these are 2. These addition of these 2 parameters is this. Now our model is ready. Okay, in which the first portion has been freezed and the remaining 2 layers can be trained. So what we can do now, we can set the environment to train the model. So what we are compiling our model, we are using the optimizer as an add-on optimizer, loss as a categorical cross entropy. Since it's having 3 categories, that's why we are using categorical cross entropy. If it's a binary, then we have to use binary cross entropy. If it's a 2 class, then go for a binary cross entropy. If it's a more than 2 class, go for the categorical cross entropy. It's a matrices, that validation matrix we are using, that monitoring we are going to use is accuracy. Now this custom model has been compiled. So environment has been set. Okay. Now let's try to run our model. So what we are going to do is we are going to run our model. Look at here. So what we have done now, from Kira's callback points, model checkpoints. Okay, we have selected a file path here. It's a file path. Okay. Now let's say why we are taking it, so that we can store our model in one place, so that it can be used. This is file path where I want to store my model. And to store a model, we use .Keras. Earlier it was HDF5. Okay. Now we are using .Keras file. Okay. This is where my model will be stored. Okay. So that I have setting a checkpoints here. So model checkpoint will be there. File path, this path is there. Okay. Model checkpoint. Monitoring is there. Validation accuracy. Verbose is 1. Verbose is 1. It means the detailing it will print as 1. It will be from little bit detailing to highest detailing. Save best only is true. So let us assume we are running our model for 100 epoch. Na? So it will save best model. Now let's say in 7th epoch, it has been achieved the best. Na? So what it will do, it will save that model in this file path. Now let us, after some time, okay, let's say after in 18th epoch, it is achieving highest. Okay, so it will override this in the same path. In this way, we have set the checkpoints. Okay, so that at last we will be having best performing model. Okay, now this custom model.fit, this function is just this one line is for training a model. So to train a model, we need xtrain, label train, and to check we need validation data also, that is xlatest and label test. Okay, we are going for a 2 epoch. You can go for a number of epoch, that was your choice. Now because we don't have much time, so I am running for 1 epoch only. By batch size we have selected 16. It means at the same time it will take 16 images at a time. Callback, it means it will callback, it is going for the checkpoint that it is saving. No? Best model will be saved in this path. Verbose is 2. The detailing it will print, it will be of the second label. Now let's try to execute. It will take 8-9 minutes. It depends on the net speed actually. How much RAM has been used. Now look at here, I have already used 6 GB RAM up to this point. So till this point, if you are having any doubt, you can ask me. It is running, it will take 7-8 minutes. If you are having any doubt, you can ask me up to this point. While it is running, we can take questions from the audience. Okay. If you are having any doubt, anything, you can ask me. I will share this codes with you. Okay. Along with the data set also, so that you can test. Just you need to do nothing. Just you need to click on this play button. Everything will be executed. Now, where you have to change is just these 4 lines. Let's say if you want to change a different model, na? if you want to go for a VGG 16 or DenseNet 16, sorry, VGG 19 or DenseNet, if you want to implement VGG 19 now, then you don't need to do anything. Just you have to change this VGG 16 to 19 in these two places only, here and here. If you want to import a DenseNet, then import DenseNet. Just you have to change this paragraph by using this, by calling this function. Look at here. It was earlier, it was VGG. Now let's say ResNet 50 if you want to call. Now ResNet 50 function is there. You have to use this function apart from this VGG function. That's say import just ResNet. Okay. If you want to use any other version or any other, let's say mobile net, if you want to use, so these are the version. Look at here. You have to use this function in place of our VGG 16 function. Okay, that's that simple change you need to do. Then you will be good to go with all these models. Literally, you are having 30-40 models that are ready to use. It will take few seconds. I have already executed it. Can we show it so that we can move ahead? Up to this point, it is clear. If you are having any doubt, you can ask me. Anyone is having any doubt? It will take few more minutes. Okay. Participants, if you are having any doubt, you can ask me. Usually it takes 7-8 minutes for one epoch. Okay. Generally what we used to do, we used to set it for 50 epochs and we used to left it for 7-8 hours so that you can get a result after 30-40 epochs. Okay. If you want high processing unit, then you have to pay. Okay. It's a paid, you can opt for a paid version. All the other versions are paid versions. They are having hundreds of GB of RAM. So your execution will be faster. If you are having any doubt till this point, you can ask me. It will take few seconds only. Now, once it has been done, the result, how we can print, we will discuss. Let's okay. Once let's say your model has been done, then you have to call this function. Why? Let's say if you have run for 50 epoch and you don't know which epoch has been given the best result. So we can get that best result from this our load weights, from file path. In file path, we have stored our model, best performing models weight had been stored. Then we will load it into the custom model. Okay. Now once that we will do this so that our custom model will be having best performing weights. Okay. Once it has been done, then you can literally try to predict things. So for prediction, you can literally use 2-3 lines of code. Look at here, from sklearn, we are importing matrices. Okay. Then from prediction test, we are using this custom model.predict. Okay. We are passing X test. These are testing samples. We are passing it in the prediction. Okay. It is give the prediction accuracies. Now what? How we are doing? So it will give the prediction probabilities. Then we are creating a zeros like a array from a prediction test. The size, whatever size we are having here, the same size of array will be created here. Based on that array, it has been based on that array, it will convert this predicted probability into the maximum probability value having value 1. It means that the minimum probability will be set to 0 and the maximum having probability will be set to 1. So it means it will now classify in terms of 1 and 0. Okay. Then you try to print the matrices. Okay. So we have to print matrices.classification report. So we can print the classification report. Okay. Where you have to just pass the label test and prediction test. So label test means testing label that we have generated, and prediction test means the test labels generated from here. Okay. It will be passed. Based on that, just if you will execute it, it will run the and it will print entire result in terms of it will print your precision, your recall, your app score, your support use it has been used. Supports means how many sample it has been used from category 1, category 2, category 3 in during testing. It will print. Okay. At the same time, it will print micro average, macro average, weighted average, and sample average also. Micro average is inter-class average. Macro average is intra-class average. Weighted average is samples multiplied with the prediction accuracy. That is called weighted average. And sample average is normal average. So it will print everything. Okay. I can show it. Okay. Just a second. I have already executed it. It is taking time. Okay. Look at here. So I have already executed it. So after 2 epoch, we got validation accuracy as 89%. Validation loss is quite high right now. Okay, you have to train it for more epochs. For a demonstration purpose, I have just run it for 2 epochs. Okay, now just you have to print it so that look at here 89.67, but loss has been reduced, but accuracy is right now it is earlier it was 81, it has been improved to 89%. Okay, now look at here. If we want to print this, then it is printing like this. For category 1, sorry, grade 1, grade 0 means grade 1 means grade 2 means grade 3. Okay, so it has used 117 image from grade 1, 278 from grade 2, 176 from grade 1 and grade 3. And it has achieved this precision, recall, and app score. Okay, this is how you can print. I will share the code for printing ROC curve also, for printing classification report also, confusion matrix, that is, I will share. Okay. So I think we can stop here. If you are having any doubt, you can ask me. Because it is taking time. Generally, it takes 8-9 minutes for 1 epoch.
What is the kind of output we usually get when we run this?
This is the output I have shown. Na? Once you run this, so this type of output will be there. For first epoch, it will show how much accuracy has been achieved, how much loss has been achieved. Okay. Then for second epoch, it will show how much accuracy loss has been. Sorry, it was a validation and training accuracy. It was a training accuracy. It is a validation accuracy. So in the second epoch, it will again show validation and training accuracy. And we are monitoring the validation accuracy. So whenever the best validation accuracy will be achieved, that model will be saved in this path. Okay. Now let's suppose if you are running for 50 epoch and in 34th epoch you have achieved the highest accuracy, then the 34th epoch model will be saved here. So model saved means the weights of all the layers will be saved in this file path. Now once execution has been done and epoch running has been done, we are loading that weights to our custom model. So just we are passing the file where our models weight have been saved, that path has been passing. Okay, and we are just using load weights command. Okay, earlier when we were calling weights equals to true, in this case also. Look at here, weights equals to ImageNet, it is same. Load weights, we are loading the weights from the saved path.
Another question, let me ask you. We are giving permission for the Google Colab to access all our files. So
Okay.
will it access our all files from our directory and will
No.
create
To access all the file, you need to read it. It is just accessing. It means we are just mounting so that we can read. Still, you need to use functions to access all those.
I mean,
So in this case, I need to create function to read the folder. Without creating function, it can't directly read.
If I say one particular file, then only it can take.
That only it can take. You need to properly pass the path name. Then only it will read.
Open clearance, if I give, it cannot be taking all the files from my directory.
No, it can't read. It can't read anything. Just it has access so that it can read, but still you need to provide the path.
Is it the case with all the requirements for give access to my drive? Sometimes it's asking this several programs. So can we safely give that?
We can give that. Collaboratory is nothing because it's a cost thing. It is controlled by you. Whenever you want, you can terminate it.
Okay.
While you are running, it will be accessed. Okay. Once you close it, that permission will be gone.
Okay.
It's a temporary permission. Whenever you are executing this collaboratory file, till then that is active, and still you need to give the path to access.
Thank you, Mr. Thank you.
So I will give you command to print. Sorry, I will give you the function to print or a seek or everything. Everything is there. You can literally go. The notations has been done. Okay, how to plot, how to change the x direction, y direction, labels, limitations. Everything is there. How to change the color matrix also. To change color matrix, just you need to just second. Where is it? Look at here. ROC curve. A number of classes you can give. Okay, color matrix. There will be some area where we can give the color representation. Look at here. Here color we can give. Okay, here we have decided na we are using navy color. Okay, now when we are plotting the confusion matrix, look at here. It's a command to write the confusion matrix. Everything has been annotated. Here you can pass the C map. Okay, it's a color map. In this case, I am using blues color map. There are so many color maps. Just you have to search C map on the Googles to support by matplotlib. Okay, C map matplotlib. It will give you thousands of colors. So it will give you the confusion matrix. Okay. So I will share this code along with few other codes in which this modification has been done. This 1-2 line modification. Let's say it is for VGG16. Na? If you want to call densenet, then how this one section can be changed. I will share 2-3 codes so that you can understand. If anyone is having any, my email ID is I have shared my email ID in the chat box. So if you have any difficulty, you can reach me out. Okay. So I think we can stop here. If anyone is having any doubt, they can ask me. Okay. If anyone is having any doubt regarding any topic that we have covered so far, they can ask me.
Thank you so much, sir. So today we conclude the 10 hours program on advanced AI certification program. I personally thank and also on behalf of MTC Global and IIIE extend our heartfelt thanks to Dr. Jitesh Pradhan, sir. He is a busy person, but still accepted our request to be the resource person, especially being in the weekend, that to 2.5 hours. A family person is very extensive. But thank you, sir, for your time. And we also extend our heartfelt thanks to all the esteemed participants from IIIE and MTC Global, those who are part of this 10 hours program. Sir, I request you just give concluding remarks, Dr. Pradhan sir, then we will close this.
Thank you so much, sir. First of all, for this invitation, actually. Uh, so I think I have covered, I have tried to cover many things. So if participant can have any problem at any time regarding coding or any understanding of any topic, they can reach me out at any time, any point. I will definitely give them reply. Okay, it was a very nice for me to take this entire session on the deep learning. Okay, thank you all for this opportunity.
Thank you, sir. Thank you very much. Thank you, sir. Good night and bye bye.
Good night, everyone. Thank you.